Hello and welcome to CS Mentor everyone. My name is Ryan and I will be your tutor for this course. In this course we're going to learn all about JavaScript, and in this first lesson I'm going to give you an introduction to JavaScript, which will include some basic programs and things that you can program up yourself if you're following along with me. So what we're going to get started off with is to write our first program. We're going to go to our web browser. So in my case, I'm using Google Chrome, but you can use whatever web browser you want, Internet Explorer, Firefox. And when we go to our internet browser, I want you to go to the website JSBin. So if we type in JSBin and we hit enter, it should be the first link that pops up, but just look for jsbin.com, this first one here, and we're going to click on it. And now that we're inside JSBin, we can see that we have two windows that have popped up. So we have a HTML and we have an output. So we're not actually going to be using HTML in this video, we're going to be using JavaScript. So we're going to get rid of that HTML window and we're going to open up the JavaScript window. And to see our results, we're not going to actually see it in output, but we're going to see it within the console. So we're going to close down out of this output window and we're going to open up the console window. And our first program will be to just print out something to the screen. We want to get our computer to go and say something to us. So traditionally what we do in this case is we get the computer to say hello world. So that's what we're going to do in this video as well. So we're going to type in console.log. So console.log. And you can just think of console.log as something that allows us as users or programmers to see what the computer is actually doing. So after we have said console.log, we're going to type in two brackets. So we're going to type in two quotation marks. Okay, so whatever we put within these two quotation marks will be what's displayed out to the screen. So for example, if I put hello world, hello world will be displayed out onto the screen. And to run this program, we can just hit the run button over here on the right hand side, and then within our console here we will see the result. So if we try that now, we can see that hello world has been printed out. Okay, so if we want to change this program slightly to make it a little bit more personal, we could take out the world and we could add in something else. So for example, my name's Ryan, so I'm going to put in Ryan. If your name is something else, you can put in your name here and we'll hopefully get the computer to greet you. So if we run this again, we can see that it now says hello Ryan. And if we want, we can clear all the previous results. So by just hitting this clear button, so we can clear it. And then if we run this again, we will see hello Ryan again. Brilliant. So we just clear that again. Now, apart from writing just text, such as, letters and words within this, we can also write numbers. Okay, so we could have something like we could have Ryan is, we'll say 25, and we can click run and we can see that it prints out Ryan is 25. Okay, so that's kind of cool, but we're still having to manually put in whatever we want to print out. So there's this idea of variables that we'll touch on in another video, but the idea is that we can store some information in a variable. Okay, you can just think of a variable like a like a bucket or something that we can store information in, and then when we want to go and retrieve that information, if we want to go and print that information, let's say, we can just go and call that variable or that bucket that we want to print the contents of. So if we want to make a variable, we can make it like this. Don't worry about what I'm doing too much. This is only a JavaScript introduction video just to give you an idea of some of the things that we can do. So I'm going to type in let, and then I'm going to type in the name of my variable or bucket, and I'm going to name it name, okay, and I'm going to equal it to something else. So we'll say Chris. So now what I can do is inside my console log, instead of writing any text, and you'll also notice that I've got rid of the 2 quotation marks, so, or the double quotation marks. So what I'm going to do now is I'm going to type in here the name. So the name in this case is the name of my variable. So if we go and run this, we can expect to see the name Chris. Okay, so I'm just going to clear this and I'm going to run it, and we can see that it prints out Chris. And just to be quite clear on how it prints out this word Chris, it's getting it from this name, but this name could be anything, right? So you could name this me, let's say, and then you would have to change what you want to print out. For example, you would now not be printing out name because name does not exist. You'd have to print out me. Okay, so if we print out me, I'm just going to clear this again, and I'm going to run it, and we can see the exact same thing gets printed out. So that's one way that we can print out things, like changing it in one place. Like, I can change this to Ryan, and if I go and run this program again, it's going to print out Ryan. Yeah, so it saves me from constantly changing my text within the console log. I can just create a variable and just change that variable. And another thing we'll touch on for the end of this video is some things we can do with numbers. Okay, so we can set a number to a variable as well, but just for now I'm going to keep it simple. Okay, so we're going to type in, we're going to type in a number here, for example, right? Let's say 6. And if we go and clear this and we want to see the number 6 being printed out on the screen, we can see the number 6, right? So that's okay. But if we wanted to do something else with the 6, so let's say we wanted to, add, another number, let's say. So we can do the plus, and we can do 7. So you commonly see this in maths, but it's just nice to know that the computer can also do this for you as well. So if we go and clear this and then run it, we can see that 13 is displayed to the console, which is what 6 and 7 are. But what we can also do is, similar to the way that we were changing our name variables, we can set a variable. Let's say let's say number 1, and we can give it a value of 6. So this outcome is going to be the exact same as what we got previous, but it's a different way of doing it, and it's a better way of doing it. So, and you mightn't see the benefit of it now, but you will in future videos. And then we're going to have number 2. So we just have 2 variables. One's called number 1, one's called number 2, and we've set number 1's value to 6, and we've set number 2's value to 7. And what we're going to need to do in here is we're going to need to add these 2 values together. So number 1 plus number 2, and then if we clear this and we run it again, we can see that the number 13 is being displayed. So it's the exact same result, and it's the exact same way of doing it as the previous way. You might be wondering, is this not a little bit more effort? And for a simple program like this, yeah, you could see it as being a little bit more effort to declare the variables and then print them out within the console log. But where this becomes useful is if you had loads of different variables here. If you had loads of different variables, and let's say only one of them has changed or something, then all you have to do is change this variable. So I can change this from a 7 to a 10. Okay, and everything else is going to be perfect. Everything's going to work. Once I've just changed that variable. If I change that console log, it might need to be changed in several other places. So what we're going to do is we're going to clear it and we're going to run again, and we can see that now our new total is 16. And we can even make this cleaner, and we will in the future. But for now, this was just to give you a quick idea of what JavaScript is and how it can be used. Hello everyone, in this video we're going to be running our JavaScript code on our actual laptop. So if you remember in our last video, we were running our JavaScript using Google Chrome. We went to a website, and the website allowed us to run our JavaScript code. What we're going to do in this video is we're going to go and we're going to download some software, and with this software it'll allow us to write our JavaScript code on our computer, and then we can run that code on our computer. So previously we had to go and use Google Chrome, so we needed an internet connection. And if we didn't have an internet connection, we weren't able to program our JavaScript code. Now, if you want, you can skip this video and you'll be able to follow on with the rest of this course by using JSBin and typing in all the code that you'll see me typing in for the rest of these videos. But if you want to go and use an IDE, you can follow along with this video. There's a lot of benefits to using an IDE. So along with being able to run your programs offline when you don't have an internet connection, it's also good for when you want to save programs. So if you notice, if you go back into JSBin, or if I go back into JSBin now, you'll see the progress that I had the last time will now be gone. So if I go into JSBin and I go into the same link as before, you can see that I'm given this default display that I was given last time. Remember we had to close down out of HTML and open up the JavaScript. But you can see when I do this that all my progress is gone. So that's why we have a little bit of an issue with JSBin. If you want to save your JavaScript code every time you use JSBin, you're going to have to go and copy all the text that you, like if you had something like console.log and then you had Ryan. If I wanted to save this, I would have to copy all this text, and it's okay because in this case it's only one line of code. But you can imagine in the future when you have multiple lines of code, you'd have to copy all them lines of code and you'd have to put them into like somewhere on your computer. So you'd have to open up like a Word, like a Microsoft Word document or like a text document or something like that, and you'd have to paste it in there and save it. That can be quite difficult, and especially as you build multiple different programs, it can be quite difficult to keep track of all of them. So a much easier solution is to use a text editor or an IDE. So in this case, what we're going to use is called Visual Studio Code. And Visual Studio Code allows us to write all the JavaScript code we want. We can then save it. It'll be saved on our machine, and next time we go and open up Visual Studio Code, which is a software, our code that we were working on previous is there, and we can just start making changes to it. So what we're going to do is we're going to go to our web browser. So, and I'm going to type in Visual Studio Code. So if we type in Visual Studio Code and we hit enter, you can see at the very top you should get the Visual Studio Code link. If not, go to this address here, so code.visualstudio.com, and then we're going to click on this. Now what we want to do is we want to download this software. So depending on what operating system you're using, I'm going to hit this download button here, and it's going to give us some options. So you can see we have three different operating systems. We have Windows, we have Linux, and we have Mac. Now if you don't know what operating system you're using, you're more than likely using Windows. Over 90% of people that use a computer use Windows. Okay, so it doesn't matter if you have Windows 7, Windows 8, Windows 10, it'll all work by downloading this. Now one thing you have to keep in mind is there's two different options for Windows machines. So if you have if you've bought your laptop in the last maybe 8 years or so, it's more than likely a 64-bit machine. Most of the machines are 64-bit. If your laptop is over 10 years old, or your computer's over 10 years old, it may possibly be a 32-bit computer. Now one way of checking this, and a quick way of checking this, is if we go to the search bar. So some of you might have a search bar here. You can also hit this little Windows icon and a search bar will come up, and what we need to go to is Control Panel. It's called Control Panel. So you can see there, Control Panel, this is the one that we're going to go to, and when we open this up we'll see some options. Okay, so what we need to go to is we want to find out information on the computer, so on our system. So we're going to go to System and Security, and then after we've gone to System and Security, we want to go to System. So when we go to System, it's going to give us some information on our computer. So we can see some information like the RAM and the processor and things like this, but we're not interested in all this information now. We want to go and see what type the system is. So we can see here for system type, we can see it's a 64-bit operating system with a 64-bit based processor. So that's the information we wanted. We want to know if it's a 64-bit machine or a 32-bit machine. In this case it's 64, and for most of you it'll be a 64-bit. So what we're going to do is, then below this there's another three options. So the easiest option to pick is this first one here, because it's an installer. So basically it guides you through the whole installation process of the software. You kind of only have to go through and keep clicking next, while the other ones might be a little bit more complicated. So we're going to click on the 64-bit, and now we can see down here, and I'm going to double click this here to open it. As I was saying, this software that we're using is free, so anyone can download it. The reason why I'm picking Visual Studio Code over some of the other ones are some other ones you have to pay for, and I think as far as the free IDEs go, I think that Visual Studio Code is one of the best. So we can see here there's some terms and conditions. We're going to have to accept these if we want to continue. So we click next. Now what's happening here is we're choosing a location on our laptop where we want to download the Visual Studio software. Okay, so this isn't like super crucial for you to understand. You can just follow along with me by clicking next. You've got some options here, like if you want to create a desktop icon, like for example, if you want, you can untick it if you want and leave everything else as default. So this is just confirming all the information that we've done. So now the installation is taking place. It shouldn't take very long. Another thing I like about Visual Studio Code over some of the other IDEs, along with it being free, it's quite lightweight. And what I mean by lightweight is if you have a computer that is a little bit old, or a computer that isn't very powerful, maybe it was bought and it was quite cheap, when you download some of the other software, it can be quite hard on the machine or the computer. And what I mean by that is it can be quite slow to load up, and it can be quite slow to run your JavaScript programs. But with this, it's quite lightweight, as I said, so it's quite usable even on laptops and computers that don't have really good specs. So we're finished this now, so we can tick this to launch Visual Studio Code straight after we finished. So we want to open up Visual Studio Code, so we're going to click, we're going to leave that box ticked, and we no longer need our web browser, so we're going to close down out of that, and we can see that it has opened up here. Okay, so this is our Visual Studio Code software. So this stuff mightn't pop up for you. This is because I had previously installed Visual Studio Code. So what you'll see is probably something a little bit more like this. So if I go to File, if you go to File and then you go to Open Folder, and what we're going to do is we're going to create a new folder that we can go and do all our JavaScript code in. So you can call the folder whatever you want, but if you right click inside here, this menu here will pop up, and if you go down to New, and then after New you go up to Folder here, this will create a new folder. And now we're going to pick a name for the folder. So you can pick whatever you want, but I'm going to pick JavaScript because I think it's a good name. So after we have selected our JavaScript name, we're going to click on our JavaScript folder, and then we're going to select that folder. So this is just asking me, do I want to save my information? This won't happen for you, so you don't have to worry about this menu popping up. I'm going to save all of them. So now what you're going to see is basically this welcome screen here, right? This is what all you guys should see. So we can close down out of this because we're not really interested in what it has to offer. We'll be going through all the information in this course. So what we're going to do now is we're going to create a brand new file. So anytime that we want to create a program that contains JavaScript, we need to create a file to program and run our JavaScript. So on this little thing here that looks like a page with a plus, this is how we create a new file. So we're going to create a new file, and we're going to just call it let's say Hello World, okay? Because that's one of the first programs that we wrote using our JSBin software. So we'll say Hello World, okay? And along with Hello World, that's a good name for our file. But what we need to do is we need to put an extension, it's called. And an extension is just a file type. So there's loads of different types of files. So this type of file that we're creating is going to be called a JavaScript file. So the extension for a JavaScript file is .js. So .js. If we put anything else, like if we put like, you know, dot or y at the end of this, it doesn't make any sense. The computer doesn't know what type of file an or y file is. There's no such thing as an or y file. There's an or file, but there's no such thing as an or y file. So we need to type in .js so the computer knows that this is a JavaScript file that we want to use. And then we're just going to hit our enter button. So we're going to hit enter. And now we can see that we've created a JavaScript file. And what we're going to do in this, similar to what we've done in our previous video, we're going to do our hello world program. So how do we do that program again? So if you remember, we used console.log and then we put hello world in quotation marks. So if we do console.log and then we do our opening brackets and then we do our quotations and then we do hello world. So now we can see that this should run. This looks like if we put this into JS bin, it looks like it would print out hello world. So how do we do that in Visual Studio? So what we need to do is we need to go up and we need to press this run button, and after we press run, we're going to run without debugging. Okay, that's what we're going to do. And when we do this, we can see on the bottom of the screen here, hello world pops up. So this program actually worked. And again, to go and change this, just to make sure that we can make edits, we can put in our name here. So my name's Ryan. So I'm going to go back up here. I'm going to click run. I'm going to go run without debugging. And we should see hello Ryan. Brilliant. So that's our software installed on our machine. And we have wrote two basic programs. And in the next video, we're going to get started in some more complicated programs. Hello everyone, in this video we're going to be talking about JavaScript arithmetic operators. So as you can see here, there are 7 different types. Most of these you would be familiar with, you would have seen in maths, but I'm going to be going through them all anyway because there's some of them that's slightly different while programming. So, and then there's also another couple of additional ones that you probably wouldn't have seen before. So starting off with addition, this is simply just adding 2 variables together. So if we're using numbers, we can add 2 numbers together. If we're adding 2 strings, we can also add 2 strings together. Then we move on to subtraction. It's exactly what you would have used in maths before. It's just taking 2 numbers away from each other. Then multiplication is the same thing that you would have seen in maths as well. The only thing to keep in mind with this is rather than using like an x to multiply like 2 numbers, like 5 multiplied by 5, we wouldn't actually be able to do this. We'd have to do something like 5 and then this little star, or we can call it an asterisk, 5. So this here would be our solution to multiply 2 numbers. Then if we move on to division, we can see it's a little bit different as well. So usually we might have something like 10 and then we would have a divide sign which would look like this, and then by 5, and we would get our answer. While if we wanted to do a division within JavaScript, we'd have to do something like this. It would be 10 and then it would be this thing that's called a forward slash, which is this. And the forward slash will allow us to divide. And this line here is the exact same as this line here. Only in this line here, you would use it in maths, while in JavaScript we use this. So moving on to the modulo operator or modulus. This is the same thing that we would have seen in remainder in maths. So for example, if you have like a number, if you have, let's say 15, and you want to get the remainder of, 5 into 15, you can do 15 and then you can do modular 5, and this answer will be 0 because 5 goes into 15 evenly, so there's no remainder left over. But if we had something like 14 modulus 5, 5 would go into 10 twice, but we don't have enough to go into 15. We're missing one, so we would actually have a remainder of 4 in this example here for 14. Again, 15, it would be 0 because it goes in evenly. If we done something like 20 modulo 5, we would get the exact same answer for 20 modulo 5 as 15 modulo 5. These would both equal 0. These next two operators might look quite difficult or quite different, but they're actually pretty simple. So for our increment, if we have a number and we want to increment just by 1, we can use this operator. So for example, if we have 5 and we done like 5 plus plus, we would then get 6. So this would be equivalent to 6. And then similar with the decrement operator, if we had 5 and we done minus minus, we would get 4. So it just takes 1 from it. So now we're going to jump into some JavaScript and we're going to actually start programming using these operators that we've learned. So in our last video, we had just installed our IED, Visual Studio Code, and we had ran a basic application, a Hello World application. So what we can do now is we can close down out of this. You can save it if you want. I'm going to save it. And we're going to need to create a brand new file. So you can call this file whatever you want. It doesn't actually matter what you name it. I'm going to call mine arithmetikoperators.js. Remember to add in the .js because the .js is our file extension. If we don't add this in, our computer won't know what to do with the code that we type inside of it. So if we go and just hit enter, and then we can open up our file. So what we want to do now is we want to use these operators that we've learned. So like always, we're going to console log it to the screen so we can actually see what the computer is doing. So if we do console.log and we do 2 brackets and we just put in a number just to make sure that you know we've created our file correctly and that everything's working. So we're going to go to run and I'm going to go to run without debugging, and we can see 5 is displayed. So this is working. So if we want to use the addition operator that we've learned about, we can just do plus, and then we can do whatever number you want. I'm going to pick 7, so in this case 5 plus 7 should equal 12. So we're going to run this and make sure that it works for us. So we go up to run again, and then we'll go run without debugging, and we can see we've got 12. Brilliant. So now we're going to try adding 2 strings together. So just keep in mind this plus operator or addition operator can be used for both numbers and strings. So maybe we have 2 strings. Maybe we have, let's say, Ryan, and then again we're going to put in our plus, and we're going to put in a second string, and we're just going to put in Hill. Okay, and we're going to run this and see what our output will be. And we can see Ryan Hill is displayed. We can also notice that Ryan Hill is kind of pushed together and squished. To get around this, for this example, we're just going to put a space in between Ryan and Hill. So if we go and run this again, we can see that there's now a space between Ryan and Hill. That's the addition operator. Next, we're going to move on to the subtraction operator. So if we go back to using numbers, we can pick whatever number we want. Let's say maybe 10, and then we'll do minus, and we'll do 3. So in this case, we would expect to see the output 7. So if we run this, we can see that 7. Now, one thing to keep in mind is, what if we use a negative number? Like, can we see negative numbers in JavaScript, or how does that work? So to test this out, we can do 10 minus 13. So 10 minus 13 will leave us with minus 3. So if we go and run this, we can see that JavaScript is able to deal with negative numbers. So that's just something to keep in mind. We're now going to move on to multiplication. So we'll clear this again, and with simple multiplication, remember we can't do like 5x5 because we're going to get a red squiggly line underneath the x and underneath the 5. This is because JavaScript doesn't know what's going on. It doesn't know what this X is doing. It thinks maybe X is to be printed out as a string, and then it has a 5 before it, so it doesn't know what's going on. So we need to say we want to multiply 5 by 5. So we use this asterisk or star sign, and then we put in 5. And now we should see that 5 multiplied by 5 is 25. So we'll run this to make sure we're right. And we can see 25 is being displayed. Now we're going to move on to division. So we're going to pick another two numbers. We'll pick 10. So 10, and then remember, again, there's no division sign on our computer or on our keyboard. So we're going to have to use this forward slash. Now this forward slash will, depending on your keyboard, it's usually located near the bottom right of your keyboard. You'll see a question mark, and you might see a shift key. So beside that question mark, there's also a forward slash. So if you go and press that question mark key, you'll see a forward slash. Now we want to divide by the number 5. So we're going to see our output now. We're going to run our program. So run, and we can see our output is 2 because 2 divides into 10 twice. Now if we had a number like maybe 5.2, what would happen here? Because 5.2 doesn't actually divide into 10 evenly, at least. So if we go and run this, we can see that we get 1.9230 and a bunch of other numbers. So we can see that by using our JavaScript programs, we can create numbers, we can create whole numbers that we've seen before, and we can create strings, but we can also create decimal numbers, or some people call them floating point numbers. So if you hear the term float or decimal, you just know that it has a decimal place, and it could have maybe 2 numbers after it. It could be 2 decimal places, or this one here has many more. After division, we're going to talk about the modulo operator. So the modulo operator is the percent sign on our keyboard. So if we want to locate that, it's usually at the number 5, but to access the percent sign, we need to locate the shift key on our keyboard, and we need to hold down shift and then press 5, and we'll see something like this. Okay, so we're going to just get rid of this, and we're going to pick 2 numbers again. We're going to pick maybe 15, and then we're going to pick modulo and then 5, and we're going to run this and see what our output is. So if we go up here and we hit run, and then we go run without debugging, we can see 0, and the reason that we get 0 is because 5 divides into 15 perfectly. There's no remainder. So it doesn't matter like how many times the number on the right divides into the number on the left. So it doesn't matter how many times 5 divides into 15. It's, you know, if it divides in evenly, the answer is always going to be 0, because again, remember, it's the remainder that we're looking at. So if I was to change this to something like, 20, it would still be the same thing, because 5 goes into 15 3 times and there's nothing left over, and 5 goes into 20 4 times and there's nothing left over. So if we go and run this, we'll see that our answer is still 0, and we could put whatever we want. We could put even 200 in here and we're still going to get the same output. But if we done something like, let's say one of the numbers we used before was 15, and we got our output as 0. But if we used 14, so we just took one away from it, notice here that 5 will not divide into 14. 5 will divide into 14, but there'll be a remainder. So 5 can divide into 5, 5 can divide into 10, and then between 10 and 15 is where our number 14 is located. So 5 will divide into 10 twice, that's fine, but there'll be 4 left over. There's a remainder of 4. So if we go and run this, we'll see that our output will be 4. I hope that's clear. Now the next thing that we're going to move on to is going to be our increment and decrement operators. So this is quite simple. We're going to define a variable for this. So we're going to just we'll call it num. So we'll say let num, and then we'll set it to 5. Okay. And then what we're going to do is we're going to get our num, and we're going to use the increment operator. So we're going to just do 2 plus signs, and then we're going to console log our number to see what our result is. So if we go and run this, we should see 5 plus 1, which would be 6, and we see 6. If we didn't have this line, so imagine we took this away and we went to run it, we'd see 5, because all that we've got here is we've defined a num and we've set its value to 5 and we're printing it out. And then if we had num and we use the increment operator, we're just adding 1 to that. Like, we could also have a second one, so we could have another num plus plus. So what would happen here is, you could imagine we start off with the number 5, then we get to this line and we want to add 1 to the number, so we have it equal 6. Then we get to this other line, we want to add another 1 to it, then we would have it to equal 7, and then we print it out. So let's run this and see, do we get 7? So we can see we get 7. Now, quite similar with the decrement operator, instead of using pluses, we just use 2 minus signs, okay? So now what are we doing? We're defining 5, again, the same with our increment operator. Then we're moving down to this line and we're taking 1 from it. So 5 minus 1, remember, every time we're using these, it's only taking away 1. So we're taking away 1, so our number will be 4. So if we run this just to make sure, yeah, we can see that our output is 4. Hello everyone, in this video we're going to talk about variables in JavaScript. So on our last video we talked about arithmetic operations. So in this video we're going to talk about variables in JavaScript. So we're going to start off by creating our new file. So I'm going to call mine variables.js, and I'm going to close down out this file because we don't need it. So one thing to keep in mind when we're programming in JavaScript is we need to use variables, and we need to use variables to store our data. So our data could be anything. Our data could be a string, our data could be a number. So the 2 main data types are strings and numbers, and when we think of a string, we think of a number of characters. So, you know, we might store somebody's name in a string, or we might store somebody's favorite food in a string, but there's other things that we can store in strings as well. And we can also store numbers in strings. So if we can think of an example that contains both letters and numbers, so something like this might be a number plate. So a number plate would contain both numbers and strings. So we could only store that number plate variable within a string. We couldn't store that number plate variable within a number, because if we use numbers, it doesn't allow any characters to be used. So we'll just start off with our string here. So we'll call it name. And within our name variable, we're going to let it equal Ryan. So I'm going to type in Ryan here. Now we can see that Ryan is being stored in name, but this line of JavaScript isn't actually finished yet. We need to specify whether this variable, name, is going to be changed at a later date. And how we do that is, before we specify the name, we either use let or we use const. And for this example, we're talking about names. So generally your first name doesn't change. Sometimes your second name might change if you get married, but for your first name, we'll leave it as const. So we'll assume it doesn't change. Then another variable that we could take into consideration is a number. So for example, we might think of an age, right? So we might have age and we might set it equal to a number. So let's say 25. Now our age changes, you know, every year. So this variable will need to be changed at some stage. So we'll set this to let, okay? So now we're going to console log these 2 values just to see what our output will be. Our output should be Ryan and 25. So we'll do console.log, and we'll do our brackets, and we'll just copy and paste this, and we'll put in our name inside the first console log, and we'll put in our age inside our second console log, and we now go and run this. So we can see our output here is Ryan and 25. So now let's say for some reason we wanted to change our name Ryan. So our first name usually doesn't change, but we're going to try and change it in this example. So we're going to have name, and we're going to set it equal to Chris. Okay, so I'm going to put in Chris, and we're just going to try and run this program as it is, and we can see that we get all this red text, and what this is an error. So it's basically telling us that we can't assign Chris to name because name is declared as a constant. So just to make it clear, if we change this to let, so this is saying that name can actually be changed, and we go and run this exact same code, we can see that Chris is now printed out, and it says Chris and the number 25. So as I said before, our first names usually don't change, so we're going to want to make this constant, and we're going to get rid of this because we're not changing our name. So now we've got this let age 25, and from before we know if we use the let keyword that we can change our age, and it shouldn't give us an error. So to change our age, let's say age plus plus. So if you remember from our previous video, when we use the plus plus increment operator, it will increase our number by 1. So we should see 26. And we can see the output displayed is Ryan and 26. But we could also assign a completely different age. Okay, so we could say age is equal to maybe 30. And then we'd see our output as 30. And so we do, we see Ryan and 30. And imagine if we change this to const, we would then not be able to change our name on this line. So if we could try and run this, we can see that we get an error. So we need to change this back to let, because we want to be able to change our age. And we'll take this away. So if we go and run this now, we'll see the result of Ryan and 25. Currently using pretty basic information, so let's go and change this up a little bit. So we're going to get rid of our name, and we're going to get rid of our age, and we're going to keep our two console logs, but we're going to get rid of the variables within inside them, because we're going to create two new variables. And the first variable that we're going to create is just going to be a license plate number. Okay, so we're going to just say license, and we're going to let it equal to a license plate number. So if we remember, a license plate number will contain both numbers and letters. So if it contains both numbers and letters, we're going to have to use a string for this. And we can put in, let's say, 16.1, and then we put in hyphen, put in LM, and then you can put in whatever number you want. So now, is our license plate going to change? Our license plate on our car will never change. You know, you might replace the tires, you might replace the engine, but the license plate on the car will never change. So we're going to leave this as a constant, meaning that it will not change. Then the second value that we want to input is going to be the height. I'm choosing the variable height because the height will have a decimal point in it. You could use something like the weight of the car, you could specify the speed, you could specify the duration it takes to get from 0 to 60, whatever you want to use, but I'm just going to use height because it's straightforward. So we're going to say HD height, and we're going to say it's equal to, we'll say 165. Okay, so the unit that this is being measured in is centimeters, but we're not going to specify this in this example. We're just going to say the height. We're going to assume that all our vehicles are being calculated with the exact same height. So the height of the car may change. So depending on the type of tires you put on, or if you raise or lower the suspension. So we want to put this as a let. And we can see, if we print these out, we'll see license and we'll see height. So currently, if we print these out, we'd see that our license plate number and our height are the same as the values we've assigned to it. But when we're dealing with numbers in JavaScript, we can also do decimal points. So we can say 165.5, and we can go and run this, and we can see that 165.5 is being displayed. Or we can also change this to have multiple decimal places, so as many as we want. So we could say this, and we run this, and we can see that it gives a more precise measurement. Hello everyone, in this video we're going to talk about assignment operators. Now in our last video we talked about variables. If you remember in the video prior to that, we talked about arithmetic operators. So using our incrementing by 1, incrementing by 2, but this time we're going to be using a different type of operator, and these are called assignment operators. There are 6 different types of assignment operators that we're going to cover in this video. So we're going to start off by creating our file. So again, you can call it whatever you want. I'm going to call mine assignmentoperators.jas. And notice the convention, or the way that I name my files. So for the first word, it's all lowercase. As you can see, there's a small a, a small s, a small s. And then when you go to look at the second word, it starts with a capital. So this convention is called camel case. So you can follow this along with your own code. It's a very popular naming convention for files, and I feel it also leaves your files much easier to read. So let's open our blank file, and we're going to just start off by creating 2 variables. So we just say num1 and num2. So we're going to say num1 and we're going to let it equal to 8. So we'll type in let num1 equals 8, and I'm just going to copy this line and I'm going to paste it down on the following line. I'm just going to change this number 8 to number 2, and then change the name of the variable, because remember, we can't have 2 variables of the same name, so we're just going to call this num2. Now if we want to console log these 2, we've done this before, so I'm just going to quickly run through it. So you can see I've console logged our 2 variables, num1 and num2, and we can see our outputs is 2 and 8, as would be expected with this program. Now the first assignment operator that I'm going to talk about, we've actually used it, and that's the equals operator. And we can see it here and here. And what the equals operator does is it takes whatever value we want. So for example, in num2, we are taking 2 and we're putting 2 into the num2 variable, and then we're printing out that num2 variable in the console log. So I think we all get this idea. So I'm going to jump into the more complex ones. They're not actually that difficult, but there would be something that you wouldn't have seen in traditional maths before. So if we wanted to maybe, let's say, add a number to num2, so let's say we wanted to add maybe 5 to it, so then num2 would equal 7. So what we can do is we could have something like this. Now make sure that we need to have this statement before we console log our num2. So we could put it here after the console log num1, or we could put it here. Either way is fine. So I'm just going to put it here, and I'm going to say num2, and then I'm going to put this plus, and then I'm going to put an equals. And the syntax is a little bit funny, but this is what it does. So as I said before, I want to add 5 to the number, so I'm going to put 5 in there. And what this line does of JavaScript, it actually adds 5 to whatever the current number is. So if we go and run this, you'll see the output. And we go run, we can see that we get 7 here. And this might look a little bit funny to you, or a little bit unusual. One way we can think about this is we could do another line here, right? And this additional line is not going to affect our program, but I just want to explain to you that these 2 lines do exactly the same thing. So we could have num2, and then we could have it equal, let's say, 7, like this, right? So imagine this line didn't exist, right? We'd run through our code, we would see our num2 is equal to the number 2, Then we go down through here, we console log the number 1, we can see it here, which is 8, and then when we hit this line, because we're imagining that this line here just doesn't exist, when we hit this line, we're placing the number 7 into num2, and then when it's displayed as 7. Now what we can also do is we could also do something like this, so we could have like num2 plus and then whatever number we want. So the number we used before was the number 5, so let's do that. So let's run this and see what result we get. We should get the exact same output, and so we do. We can see 8 and 7. So the idea is, rather than doing this here, so we can also use our assignment operator in this case. So the same thing to do would be num2 and then plus equals, and then we have whatever number we want. So we're going to just pick 5 in this case. So we're not going to see 7 when we go and run this program anymore, because if we think about it, we start off with num2 equaling 2, then we get down to this line and we're setting num2 to num2, which is 2 plus 5. So 2 plus 5 is 7. Now 7 has been put into this number 2 variable. Then when we follow up by going to the next line, num2 plus equals 5, what we're doing here is we're adding 5 to num2, so 5 plus num2, or the contents of num2, which is 7, so 7 plus 5 will equal 12. So if we go and just run this to see our output, we can run, and we can see our output is 8 and 12. So now I hope you've got a grasp on the basic idea of these operators. So now I'm going to just run through some of the other operators that we can use quickly, because they're quite similar. So let's get rid of all this code for a minute, and we'll just leave our num1 in our console log. So now if we go and run this, we should only see the number 8 being displayed. So this is great. So we want to change our num1 now. So what we want to do is we want to take some value away from it. So quite similar to the way we added values, we can subtract them in a very, very similar way. So if we select our variable, which in this case is num1, so we're going to select num1 and then we're going to perform our operation. So in this example we're going to be taken away, so we're going to go minus, and then we're going to go equals, and whatever number we want to take away from our num1. So in this case we're going to take away 4, so 4 from 8 will leave us with 4. So when we go and run this, we should see our output as 4, and we can see it's 4. Now similar to plus and minus, we can also use our multiplication, division and our modulo operator that we have learnt in our previous video. So to just go and divide, we change our minus to our divide sign. Remember, it's / when we're programming, and we could leave the number 4 there. So let's run this and see our output. So if we go and run, we can see that our answer is 2, because 4 goes into 8 twice. Then we can also do our multiplication, so we change our division to multiplication, so we would put in our little asterisk, and then we would be multiplying 4 by 8, so 4 by 8 is 32, so we should see our output as 32. So when we run this, we can see our output is 32. So now we can move on to our modulo operator. So again, keep in mind, modulo is not the same as divide, it's getting our remainder. So if a number divides into another number evenly, it will always give 0. So if we continue with 4 for this example, so if I use the modulo operator, which is the % sign, we will get 0 as our output, because 4 goes into 8 twice. So if I run this, we will see our output as 0. Now if we picked something like 2, we would also get 0, because 2 also goes into 8 evenly. So if we go and run this, we can see that our answer is 0. But if we pick something like 3, so if we think about it, 3 can't go into 8, 3 can go into 9, and 3 can go into 6. So the difference between 8 and 6 would be 2. So our output in this case would be 2. So we're just going to run this to make sure that we're correct, and we can see that our output is 2. Hello everyone, in this video we're going to talk about strings. We can talk about how we can use strings and how we can manipulate strings to do what we want. So in the previous video we talked about assignment operators. So we're going to just create a new file, and we're going to call it strings.js. So to start off, we're going to create two variables and we're going to put in two strings for these variables. So I'm going to just set let and s1. S1 is going to be our variable name. It's going to be short for string1, and I'm going to set it equal to Ryan. So for my second string, I'm also going to have it as a let, which means I'll be able to change it. So I'm going to set its name to s2, short for string2, and I'm going to put its contents equal to hill. So if we want, we can add strings together, right? So we can see this if we use a console log. So if I just go console.log and then I place in my string names, I'll be able to see it. So for example, if I put in s1 and then I put in plus s2, right? So if I do this and I go and run it, we'll see our output. So we can see our name Ryan and our second name Hill. They're both displayed using this plus operator. Now if we were to take away this plus operator and try and run it, you would see we get a problem, okay? Because the compiler, or our computer, doesn't know what we mean by this s2. It doesn't recognize it as a second variable. So we need to put the plus operator in there. Now there's still a little bit of an issue here, and the issue is our Ryan and our Hill are both connected together. So this doesn't look great because we usually want to have a space between Ryan and Hill. So one way we could get around this is to put a space in the actual string itself. So we could put a space before the H in Hill, or we could put a space at the end of the N in Ryan. So either of these solutions would work, and I'm going to run this to show you what it would look like. So we can see that this is acceptable. It says Ryan Hill and we have a space between them. But we can also do a little bit better, okay? So at least we're using variables. It's not the same as us just creating a string in here with something like maybe Ryan Hill, okay? We could also do this and we could run this and we would get the exact same output. The problem is it's not very good from a modular approach. And when I mean modular, I mean if we wanted to change our name Ryan, let's assume that there was many different console logs within our program and they all said Ryan Hill. In that example, we would need to go through and change all the Ryans. If we wanted to change Ryan's first name or we wanted to change Ryan's second name, we'd have to go through all of them. So imagine instead of one console log here, we have maybe 3 of them. So now you can see if we wanted to change Ryan to Chris, we would have to go and change each of these 3 names to Chris. While when we're using variables like s1 and s2, we could just go and change one value. So we would change our contents up here from Ryan to Chris. But as I was saying, there's also a better approach. So let's get rid of these other 2 console logs because we don't want them. We can use a thing called a string template. String templates allow us to use normal text. So we could say my name is, and then we can use a variable name. So for this example, we could say my name is Ryan, but then if we switched out Ryan for a different name, we could then display that name. So if we do console.log and we use backticks, now backticks will be found just to the left of the number 1 on your keyboard. When we use these backticks, we can use normal text. So we can put, like, let's say something. So something will be displayed as normal text. Okay, and to make a little bit more sense of this, we'll say my name is, and then what we want to do is we want to display s1, right? So we could say our name is Ryan, like this. So if we display this, we'll see this displays what we want. So my name is Ryan, But the problem is, if I go and change this, it doesn't have any effect. We're not using the variables that we've defined here, so it's a little bit pointless even having the variables if we're going to put Ryan in here. So what we want to do is we want to use our variable name. So let's say S1. Okay, so we'll try this out. Now there's an issue with this, because when we try and run this with S1, we actually get S1 displayed, because the computer doesn't know that we want to display the variable S1. It doesn't recognize that there's a variable called S1. So to let the computer know that there's a variable that we want to use, we do this by using curly braces or curly brackets. So you'll find these over the right hand side of your keyboard near the enter button, and you're going to hold down the shift key and then you're going to hit the two brackets. So you need an opening bracket and you need a closing bracket, and just before the opening bracket you need to put a $sign. So you'll find the $sign as the number 4. So if you just hit the number 4 on your keyboard, it'll pop up with the number. Then if you hold down shift and then hit 4, you get this $sign. And notice the way that the $sign and the curly brackets are lit up in a slightly different color. So that's a good sign, and it's really useful when we're coding, because we know that this part of the code is slightly different in some way than the rest of it. So we can see this and view this orange text as normal text, and then we can view this light blue text as a variable. So if we go and run this now, we can run and we can see my name is Ryan. So you can do all sorts of cool things. So for example, we could change this S2. So rather than using Hill, we'll use James. And what we could do is you could put whatever you want in here, but just know that you can use multiple variables in the one string template. So we could have my name is Ryan and my best friend is. So rather than writing James, which we could do, but we want to use our S2 variable, so we're going to define our curly braces and we're going to put a $sign in front of that, and now we're going to put in our variable name. So this is S2, so we put in S2 and we're going to run this and see, do we get my name is Ryan and my best friend is James. So if we go and hit run, we can see my name is Ryan and my best friend is James. Hello everyone, in this video we're going to talk about comparison operators. We've talked about operators before, using assignment operators, using arithmetic operators, and in our last video we talked about strings. So let's create a new file. We'll call it comparisonOperators.js, and now I want to introduce you to a new type of variable that we haven't seen before, and it's called a boolean. And a boolean is just a variable that can have two values. It can be true or false, a little bit like binary. Binary can only be 1 or 0, so a boolean can only be true or false. So for example, if we wanted to set a variable of type boolean, we would do something like this. Let, then the name of our variable, my bool, we'll say, and then equals true. And if we wanted to console log this, we would just do console log and our name of our variable. So the name of our variable is my bool. So if we just run this, we can see the output is true. So that's what we've set it to. Now we can also put this to false. So we can have true and false. And if we run this, we'll see that we get our answer as false. So now you know what a boolean is, we can start working with them. So imagine I have my bool here as a variable, and then I want to compare it to some value. So I could have a second variable called my bool2, and I could set that to false, or I could just put in false in here. So if I'm comparing my bool, which is a false value, to a false value, which is this here, I should get a true statement because both of these are false. So if I run this, we can see that our output is true. Now if I put this as true and I was to compare my bool, which is a false variable to true, it would be false because they're not both the same. So let's go and run this. So if we go and hit run, we can see that we get true here. So if I changed my variable, my bool, to true, I would then be comparing my boolean, which is true, is equal to false, and true is not equal to false. So we're going to get false as a result. So if I go and run this, we can see that we get false. Okay, so you're probably getting the idea of it now. So I'm going to just use a different variable to switch it up a little bit, maybe if you aren't quite sure of the previous example. So I'm going to make a variable and I'm going to call it age, and age is going to equal 25. Okay, and I'm going to get rid of this inside my console log, and I'm going to use my variable age. So if it's confusing you, we're not actually going to use this variable anymore. So I'm going to get rid of this, and within our console log we're going to compare our age, our number 25, to something else. So I could have age, and I want to check to see is it equal to 24. So age is not equal to 24 because age is 25. So our output that we get should be false. So I'm going to run this, and we can see that our output is false. Now if I was to change this to 25, which it is, the age variable is 25, we should get true as a result. And we do. You can see true. Now what you can also do is you could have this in quotation marks. So you could have this 25 as a string. And if we go and hit run, you'll see our output is also true. So it doesn't actually take into consideration if it's 25 as a number or if it's 25 as a string. Now if you had something like this, 255, and we go to run this, it would tell you that it's false because 225 gets converted to a normal number and then it's compared. So we just get rid of that for the moment. Now the second operator that we're going to move on to uses a third equals, and the third equals checks for both value and type. So in this example, previously when we had our single equals and we ran this statement, it gave us true. But now if we use a third equals, it's checking for the value, which is 25, but it's also checking the type as well. So it's checking that our type is of type integer, it's not string. So in this example, if we go and run this with the treble equals, it will actually get a false value. So if we want to get a true value, or we want this to be correct, we need to take away these quotes. So then if we compare our age variable, which is 25, to the normal number 25, we get true, and so we do. Now we can move on to not equals. So not equals is represented like this. So we use an exclamation mark and then we use the equals. So we use an exclamation mark and we use equals, and this checks to see if it's not equal to. So if we look at it in this case, our age is 25 and we want to check is it not equal to this number. So is 25 not equal to 25? So this will be false because 25 is equal to 25. So if we go and run this, we'll see we get a false because we want to check to see whatever number over here on the right, we want to see if that's not equal to our variable, which is age. So if we want to get a true statement down here, we can pick any other number that's not 25. So we could pick 45. So if we pick 45 and we go and run this, we can see that we get a true value because this is not equal to 25. Now keep in mind, if we go and check using quotation marks, so if we represent our 25 as a string and we go and run it, then we'll see that we get a false value because it thinks that 25 contained in a string is the same thing as our age 25. So that'll bring me on to my next operator, which is to use an exclamation mark with two equals, and similar to the double equals and the triple equals, when you're comparing variables, this does something similar. So this double equals along with the exclamation mark will check for that the variable is both the same number and it's the same type, that they're both an integer. So now we can see that it's saying this statement is true. Age of 25 is not equal to 25 as a string. But if we were to take away these quotes, we would get a false here because it knows that they're both the same. And similar, if we use a random number like 45 and we test this, we'll get a true value. So we can see this is true. Let's move on to our next operator. So we're going to get rid of all this, and we want to see if our variable age here is greater than some number. So you're probably familiar in maths of using this greater than sign. So it's quite similar in programming in JavaScript. You use your greater than sign and then you compare whatever number. So if we wanted to put in 20 there, so let's think about it. So the age is 25. Is the age, which is 25, greater than the number 20? It is, so we should get a true value. So let's run this, and when we run this we can see that we get a true value. So if we put in a number that was higher than 25, so imagine we put in 27, we should get a different result. Down here we should see a false, and so we do. Now if we were to put in something like a string, so we use quotes and we go and compare this again, we can see that we also get false. So if you use a string to compare these, the string gets converted into a number and then gets compared like it normally would. So that's just something to keep in mind. Now along with the greater than, we have the less than operator, and it's just the inverse of our greater than. So if we go and compare this now, we'll see that this statement will be true because it's asking to see is age less than the number 27, or in this case it's the string 27, but it's the same. So we can see we get a true statement. And if we take away these quotation marks and we go and run this again, we'll see the exact same output, which is true. Now if we put a smaller value, let's say we put 22, 22 is less than 25, so we're going to get a problem here. So we're going to get a false value because 22 is not greater than 25, our age. One thing to keep in mind here as well, if we use the 25 to compare it, so if we go and look at this and we see is the age 25 less than 25, it's not. So if we look at this statement, age is less than 25, and we go and run this, we can see that our outcome will be false because 25 is not less than 25. So that brings me on to the next operator, which is greater than and less than equals. So if we put an equals at the end, so if we want to check to see is our age less than or equal to whatever number, so let's say imagine we have 27 here, okay, and we go and run this, we can see that our value is true because 27 is greater than or equal to the age, and the age is 25. Now if we put 25 here, the last time when we were just using our less than operator, we got a false value. But then this time if we put our less than sign and then an equals, it's checking to see is our value here on the right, is it equal to 25 or is it greater than? And if either of those statements are true, we'll get a true value here. So if we go and run this, we can see that we get a true value, while last time when we just used our less than operator and we ran it, we got a false value. So that's just something to keep in mind. You might need to know it. And then similar to our less than, so our greater than sign works exactly the same, only if we go and run this statement here, we'll see that we get a true value. If we were to put a number here that was greater, like 26, this would not be true because age would not be greater than or equal to. So we'll see we get a false value. And then also if we put a number smaller than age, like 24, this would be true because age is 25, so it's greater than 24. So we're going to run this and let's see we get true.
Hello everyone, in this video we're going to talk about logical operators. Now in our last JavaScript video we talked about comparison operators, so we were able to compare variables and values. So this video will be similar, but rather than just comparing one value and one variable, we can check multiple variables or multiple values in the same conditional statement. So I'll show you what I mean now in a second. So like every other coding example that we've done, we're going to go and start by creating our JavaScript file. So I'm just going to paste in logicaloperators.js. This is the name of my file. And we need to think about something that we want to compare, right? So imagine the last time if we were comparing a variable, let's say maybe age, to a number, right? So if we just go back to our previous example for a second, we can see here we had a variable named age and we were comparing it to the number 24. So we wanted to see, was it greater than, or was it equal to, or was it smaller than, depending on what conditional statement, and this is our conditional statement, depending on which one of those we used. So we could actually copy this example. So we could just copy this and bring it into our logical operators file, and we're just going to change it up a little bit, right? So rather than just checking that this age variable is maybe equal to 25, or it's greater than, or it's less than, maybe we want to check that our age is greater than 18, but it's less than maybe 65. So let's leave our age at 25, and within our console log, I'm just going to get rid of our statement for the moment. And as I said before, we want to check to see if our age is greater than 18, and then we're going to check if our age is less than 65. So to start off with, we have our age variable, so we'll say age, and we want to see if age is greater than, so we'll use the greater than sign, and we want to make sure that it's greater than 18, okay? But now I also want to check to see is the age less than 65. So you'd be thinking it would be something like this, age, the less than sign, and then 65. Okay, so you can probably see our age variable is underlined with a red squiggly line. So this is not a good sign. It means we have a problem. So in the previous video, you would have seen either this statement or this statement. You've never seen both of them together in our conditional statement with inside our brackets. So one way that we can check for both is by using an AND operator. And our AND operator is represented like this. So if you've ever seen this symbol on your keyboard before, you might have seen it before, you probably haven't used it. So if you go and look at your keyboard, you'll see the number 7 on your keyboard. So if you hold down the shift button and then you press number 7, you'll get one of these weird looking AND signs, okay? So we want to put those AND signs in between our two statements, and not just one of them, because that's something different. We have to use two. So if we use two like this, we can go and then run our program. So I can go up here, I'll hit run, and then we'll get our output down here. So this is true, because if I'm 25, my age is greater than 18, but I'm also younger than 65. Now imagine if I was to change this up a little bit. Imagine if I was to put maybe 16 here. So the problem with this is if I'm 16, I am younger than 65, but I'm not greater than 18. So this should return us a false value. And we're going to run this just to make sure that we're correct. And you can see we get false here. And it's the same if we put a value that was greater than 65, like let's say for example we put in 68. So if we have 68 in there and we go and we hit run, we'll see a false value as well. So that's one of our logical operators that we can use. That's an AND. Now along with using an AND, we can use an OR and we can use a NOT. Now if you've looked at our videos in relation to logic gates, this probably makes a lot of sense to you. If you haven't, you might want to check those out first, but we'll be going at a slow pace, so you should be able to follow along. It's just if you're having an extra little bit of trouble or whatever, just refer back to those videos, have a look at those, and then come back to this one. So I mentioned before that we have this AND operator, which is represented using these funny AND signs. We also have an OR and a NOT. So for the OR operator, we use a pipe. You can find the pipe located down the bottom left hand side just beside your Z and A button, and if you hold down shift and you press that pipe, you'll see a symbol coming up like this. So after you've hit that once, just hit it a second time, and when you've got two of those pipe symbols, That's how we represent OR. And our not is represented as an exclamation mark. So if you go and hold down Shift and you press the number 1 on your keyboard, you get this. I'm going to comment out these logical operators because if I try and run my code just like this, it won't compile, so it'll complain. So what I'm going to do this time is I'm going to replace my AND logical operator with an OR. So if you remember the last time, we got a false value here, and the reason why we got a false value is because when we use the AND operator, both our statements have to be true. So I had to have an age of greater than 18 and my age had to be less than 65. Now if we use the OR operator, we'll see that only one of our statements have to be true. So I could be, let's say, greater than 18 and also greater than 65, or I could be less than 18 but also less than 65. So if we go and run this code with our age being 68, we'll see that this value will actually be true, and we can see our value is true. Now if we used like a number from our last example, like let's say the number 25, and we go and run this, we'll see that we also get the output which is true. Now the only difference between this example and the last example is this example of 25 leaves this statement true, and it also leaves this statement true, while when we had 68 here, this statement here was the only one that was actually coming out to be true, but it didn't matter because we were using the OR operator. Same goes if we go and take away our 68 and we use, let's say, the number 15. Again, 15 is not greater than 18, but 15 is lower than 65. And you might be thinking to yourself, with this algorithm, would any number we pick not be true? And your answer is yes. If we use a number, the way that we've programmed this, we'll basically get true for any of our outputs, no matter what number we use. But imagine we didn't use a number, right? Imagine we had a check in place. Let's say if we put in something like a letter here. So if we got our quotes and we put in maybe the letter OR, let's say, and we go and run this, this would give us a false value, and we can see here we get false. So the next operator I'm going to move on to is going to be the NOT operator, and basically NOT is just the opposite of whatever we do. So if we have an equation that equals true and we use our NOT operator, it'll give us the exact opposite, so it'll give us false. Or if equation's result is false and we use the NOT operator, the answer will be true. So let's go through a quick example here. So we're just going to take everything out of this statement for a second, and we're going to get rid of this OR, and we're going to change it back to 25. Okay, so our age is 25. So let's go and console log something. So if you remember from our previous video, when we want to compare two numbers to see if they were equal, we'd use the double equals, or in some cases the triple equals, if we wanted to compare both the type and the contents. So we're just going to use the double equals in this case. So we're going to say 25, and then we're going to go equal to age. So this should come out to be true because 25 is equal to our age variable, because our age variable is set to 25. And we can see our answer here comes out to be true. Now, if we wanted the opposite of whatever result we got, for whatever reason, we can use the NOT operator. And simply, the NOT operator is just an exclamation mark. So we would go inside this bracket here, because inside the bracket is our equation, and we would have our exclamation mark. So we would go inside the bracket because the first bracket here is our console log, so our equation is inside the bracket. So we would go then and put our exclamation mark, and then we would then go and run our application, and we should get false as our value. And you see we get false. Now it's always good practice to add in an extra set of brackets. So if we were doing this, we would have something like this. We would put the 25 equals age in another bracket. So we would have the NOT operator just sitting outside of that, and then outside of that we have our bracket for our console log. Hello everyone, in this video we're going to be talking about bitwise operators in JavaScript. Now in our previous video we looked at logical operators. The way of thinking about these bitwise operators are similar to logical operators, but there's some different signs and some additional signs that were not in our logical operators. So let's jump into it. So we'll create our new file. We'll call it bitwiseoperators.js. Now what we want to do in our file is we want to create two variables that we can compare, okay? So the two variables that we're going to create, we're going to need to know what they are in a binary format. So if you don't know about binary, you don't know how to convert binary numbers to decimal or decimal numbers to binary, I would suggest that you go and look at our binary numbers videos, and then you can come back to this video and you'll have a better understanding of what we're about to do. So we're going to define two variables. We're going to keep the numbers low for this example because it'll hopefully make it a little bit easier for you guys to understand. So we'll start off with saying let, and we'll just call them num1 and num2. So num1, and we're going to set it equal to the number 5. Okay, and then we're going to set our second num equal to 1. So we'll have let num2 equals 1. Now if you've watched our binary videos, you'll know what 5 and 1 are in a binary format. So I'm going to do this just at the top. So we'll give ourselves a little bit of space, and we just want to say that we know that 5 is equal to or equivalent to the number 0, 1, 0, 1 in binary, and then our number 1 is equal to or equivalent to 0, 0, 0, 1. So we're just going to comment this out. You don't have to write this down. This is just to try and help you understand the concept of this video. So I'm going to comment this out, and the first bitwise operator that we're going to look at is the AND operator. Now if you remember from our previous video where we talked about the logical operators, we had an AND sign which looked something like this, okay? And we used two of them together. So you might remember in the previous video that I said we can't use a single AND sign, and the reason for that is because a single AND sign is used in bitwise operators, which is what we'll be dealing with today. So let's just do a console log, and we're going to use our two numbers that we specified, and we're just going to go and see the output, and we'll see does it make any sense to you. So we'll start off with our console.log, and inside our console log we'll just put in whatever number you have. You could put like the number 5 here, and then you could put an AND sign and 1, but since we have our nums defined, our num1 and our num2, you can put num1 and then our ampersand and our num2. So if we go and run this, we can see what sort of output we get. So if we run this, we get the number 1. Now does this make much sense? Probably not. You might be thinking to yourself, okay, so we've started off with our number 5, and then we've used this AND operator, and we've used the number 1. So you might be thinking like, oh, 5 plus 1 or 5 and 1 or something like that would maybe equal 6, or if you were to take it away it would equal 4, or you know, you might be a little bit confused on what's happening here. So to find out exactly what's happening, we have to look at our binary numbers here, and this is why it's so important that we know how to convert our normal numbers, the numbers that we use every day, into its binary format. So when we go and look at these, we look at them column by column by column by column. So you can see here that there's 4 columns, and when we look at the value in the rightmost column, so this one here, the one that has 1 and 1 in it, we're checking to see if both of those values have 1 in it. And if both of those numbers have 1 in it, we can say that it's true. So if I came down to this next line here, and let's say I was here, I could say there's 1 in the top row and there's 1 in the bottom row. So I could say that's equal to 1. Then if I look at the next column here, it's 0 and 0. So, you know, neither of these have 1 in it. So that would be equal to 0. And then if I go and I look at the third column here, I have a 1 and I have a 0. So again, as I mentioned before, You know, if we have just a single 1 or if it's all zeros, we can't bring a 1 down to the next line because we're using this AND operator. So when we're using AND, both of them have to be 1 or both of them have to be true. So again, here would be 0 as well. And then for the fourth column, it's the same as our second column here. Both of the values are 0. So again, we'll be bringing 0 down to the next line. And what we end up with here is the number 0001. And 0001 in binary is equal to the number just 1 in our normal numbering system that we're used to dealing with. So again, we'll just comment that out, but I'll leave it there because it might help you understand it. Now you probably have a good idea of why we got 1 as our result here. So imagine we picked two other numbers. So imagine we picked, let's say 8, and for our second number we'll pick 2. Could you imagine what our outcome would be? So I want you to think about this yourself for a second, but I'll write down the binary numbers of 8 and 2. So 8 in binary is equivalent to 1000, so it kind of looks like 1000, and our number 2 in binary is 0010. So, you know, just by looking at this, you don't have to really do too many calculations. But if you look at this first row here, you can see that there's a 0 and a 0, so you'd bring down a 0 here. And if you look at the second column, there's a 0 and a 1, so again, you can't bring down 1 in this case either, it would be 0. And same here, 0 and 0 would be 0. And again, 1 and 0, so again, they're not both 1, so it would also be 0. So our outcome for this would be 0000. So that's nothing, right? That's equivalent to 0, nothing. So if we go and run this code, does that mean that we're going to get 0 as our output? Well, let's check it out. So I'm just going to get rid of this here, because if we don't get rid of this, we'll get a compiler error and we'll not actually be able to run our code. So once I've just got rid of that, I'll go up and I'll hit the run button, and we can see that we actually do get 0. And you can play around with this, you can put in different numbers. So, you know, I know for example 7 would probably be a better number because 7 is equal to 0 with 3 ones. And then if we just left the number 2 there, or even better if we left 3, I know 3 in binary is 0011, so we should get a better output for these numbers. So I'll just go and hit run, and you can see that our number that we get is 3. Again, feel free to plug in different numbers and mess around with this yourself, but you should have the basic idea now of our AND operator. Now, if you can grasp the AND operator, the OR operator is quite similar, but rather than having these numbers and checking to see if both the columns have 1, if either of them have 1, it's kind of good enough, and you can bring 1 down to the next line. So for our previous example, or our first example where we had 5 and 1, if we go through this example really quickly, we can see in this case we have 1 and 1, so 1 and 1 again is 1 because either one of them has to be 1. In this we have 2 zeros, so there's not much we can do about that. In this one here we have 1 1, so we can actually bring down the 1 because we've got 1, and in the last column again it's going to be 0. But from looking at this, we should now get our output as 5. So let's go and run this and see if we're correct. Now again, our OR operator is very similar to our logical operator. So rather than using 2 pipe symbols, we can just get away with using 1. So this is what it'll look like. So now we're going to go up and we're going to hit run, and we'll see our output, and we can see that 5 is our output. So we now know how to deal with our OR operator and our AND operator. There's a few other operators that we have to learn about. That'll be coming up in our next video. Hello everyone, in this video we're going to be talking about bitwise operators. Now this is the second part of our bitwise operators video. In the first part we talked about our AND and our OR bitwise operator. In this one we're going to be talking about shifting bits. So shifting bits right and shifting bits left. And you're probably unfamiliar with this. So to make a little bit more sense, I'm going to go into an example, because that's usually the best way to try and understand how these programs and concepts work. So again, we're going to start off with our value. Let's say we're going to say let, and we're going to just call this one num, and we're going to set our num to 5. And we want to keep in mind our binary equivalent of 5. So it's important that you know your binary for this video also. So again, if you haven't watched our binary videos, I would recommend it. So just to fill you in, the number 5 is equivalent to 0, 1, 0, 1 in binary. And I'm just going to comment this out. So we've got this number 0, 1, 0, 1, right? So when we go and shift right or shift left, we're basically taking our number and we're putting it to the right or putting it to the left. And when we put it to the right or put it to the left, we have to cut off some of our bits. Our bits are our zeros and ones that we have here. So if you could imagine this number in a box, and if I tell you you have to move this number to the right or you have to move this number to the left, you have to cut off some of these bits. So you lose some of these bits and they get replaced by zeros. So again, this mightn't be making a lot of sense, but it will now in a second. So like in all our previous programs, how we actually see anything is we want to console log it. So we'll say console.log, and we're going to take our number, which is num. So this is our variable that represents our number 5, and we're going to shift it to the right. Okay. So to shift it to the right, we use 2 greater than signs, and then we say 1 because we want to shift it by 1 place. So for example, imagine we have this number here and we're shifting it to the right. So you can imagine this number here is going to be pushed to the right. So if this number is being pushed to the right, what's going to happen? Well, whatever number's on the end here, which is 1, is going to be separated. Okay, so 1 is going to be separated and then a 0 is going to be added on to the end here. We can think of this 1 here as just being deleted or disappears. So now we've got this number here, which is 0010, and this number here is equivalent to 2 in decimal. So if we go and run this, so let's say we go and hit run and run it out debugging, and we can see our number that we get here is 2. So what would happen if we didn't want to shift it by 1, we wanted to shift it by 2? So again, we're starting off a brand new program here. So we're going to go back to 5. So 5 is 0, 1, 0, 1. And last time we shifted by 1. So there was only one of these numbers taken away and pushed to the right. But in this scenario, we're going to be getting 2 numbers and we're going to be pushing them to the right. So we take 2 numbers, which is 0 and 1, and we push them to the right. And they basically get replaced then from 2 numbers that come in to the left. And them 2 numbers are 0. They're always 0. So again, we can imagine these 2 numbers here as being deleted or discarded. So if we go and run this now, we should expect to see whatever this number here is. So this number here in binary is equal to 1. So we should see 1 as our output. So if we go and just run this, we can see 1 is in fact our output. So that's our right shift, or some people call it signed right shift. Now if you get the basic idea with our right shift, our left shift should be pretty easy for you to pick up on. So we're going to convert this back to our binary number 0, 1, 0, 1. So that's 5 in binary. And this time we're not going to go with our greater than sign. We're going to go with our less than sign, okay? So we're going to just change this back to 1 because it might be a little bit simpler to understand at the start. So similar to last time while we were shifting right, this time we're going to be shifting left. So you could imagine last time where we got our first bit here cut off and it was separated. So similar to that, only coming from the other side. So our 0 is going to get cut off and then 0 is going to be added to the right. So if we go and basically delete 0 because it's like it's not there, and we go and run this, we should see whatever number this is. Now you may or you may not know what this number is in decimal. I can tell you now that it's equal to 10, so we need to go and check to see is our output that we get actually 10. So if we go and run this, we can see that our output is 10.
Hello everyone, in this video we're going to talk about conditional statements. Now the first conditional statement that we're going to go through is going to be the if statement. There's multiple different conditional statements that we're going to cover, but the if statement is one of the most basic conditional statements, and it's probably one of the most used conditional statements as well. So as you can see in our last video, we were talking about bitwise operators. So we're going to go and just create a new file. I'm going to call my file conditionalstatements.js. So we're going to start off by creating a file, and I'm going to call my JavaScript file conditionalstatements if.js. Now with our if statements, we can compare numbers and we can check our variables. So we can check that our variable is equal to something or that it's not equal to something, and then based on whether that is true or not, we can go and do something else. So for example, we might want to check to see if your age is greater than 16 or equal to 16. If we know that you're 16 or greater, we know that you are eligible to work. So in this example, we're going to start off with our age. So we're going to say let, and then our variable name, we'll call it age, equals 25. So you can pick whatever age you want. I'm just going to pick 25 for this example, and now we're going to actually start to use our conditional statement or our if statement, and we just simply say if, so if. Now keep in mind that this if is known as a keyword. So for example, if you wanted to create a variable, like here we've created a variable called age, you wouldn't actually be able to create a variable called if because it's this keyword. And you'll see some different keywords as we go through this JavaScript course. You know, when we talk about loops and we talk about things like that, you can't use those as your variable names either. Now what you could do is you could get around this by, let's say, adding another word at the end of this. If you wanted to create an if you wanted to have the word if in your variable name. But just for this example, we're going to focus on using the keyword if, and we're not going to worry about creating fancy variable names just yet. So we've got our if keyword, and then what follows our if keyword is two brackets, so an opening and a closing round bracket, and inside these round brackets is going to be our conditional statement or our logic or what we want to compare. So for example, we're dealing with age in this example, so we would have, you know, age is greater than, or age is not equal to, or age is equal to, or some sort of logic like that inside these brackets. So I'm going to check to see if my age is greater than 16, because if my age is greater than 16, I'm eligible to work. So to do this, we'll just say age, our variable, and then we'll put in a greater than sign because we want to make sure that our age is greater than, and now we'll put in the minimum age that you can start work at. So in Ireland it's 16, so we'll put in 16. Now a good practice for this, we can see that 16 is put in here, and some people call this hard coding, and by hard coding you're putting in this value yourself. So, you know, imagine, let's say next year or you know, in 5 or 10 years time, that the minimum age of working was changed to maybe 15 or maybe 17 or something like that. You would have to change this number in multiple places if you were making multiple checks. Now again, for this small example, it doesn't really matter because we'd only have to change our age in one place. That would be inside our if statement here. But one really good practice is to make constants, and we can make constants by, you know, having the keyword const at the top and then specifying whatever this constant variable is that we're going to use. So we could say working age, so working age like this, and we could set this variable to 16. Then we could replace this 16, it would be no longer needed, and we could replace this with working, and I can see that's O there, working age. So this would be a really good solution if we were maybe creating an application for ourselves or
an application that was, you know, a little bit bigger than this example here that we're going through. You know, this is only for practice, so we don't want to get too caught up on having everything perfect. You know, when you are developing your own applications and maybe possibly, you know, working in industry, or you might go off to college and do this type of thing, it'll be more important to have, you know, really good quality code. But for now we can get rid of this. So I'll just delete this working age and I'll put back in the number 16. And since we're not using working age, I can delete this as well. This is just to, you know, make sure that we're focusing more in on our conditional statement and that nothing else is confusing you. But I just wanted you to note that it is good practice and to keep it in mind. So now we can see with this if statement we have a red squiggly line at the second bracket. So this usually isn't a good sign. It usually means we're missing something or what we've typed is incorrect. So what we've typed so far is perfect. The only problem is there's another little bit to the conditional statement, and that extra little bit is these two brackets here. Now these brackets are slightly different. These are curly brackets, while the first set of brackets we used were round. It is important. If you use other ones, it won't compile, so your program won't work. And I'm just going to bring these down to the next line to make it a little bit more straightforward. So we're going to separate these, and within these curly brackets is going to be what our computer does. So if we wanted to add two numbers together, or if we wanted to take two numbers away, or if we just wanted to print something out to the screen, whatever we want to do, we can do it within these curly brackets. And for this example, I'm just going to print something out because it's the simplest thing and it's the most easy and straightforward way of understanding how these programs work. So we're going to console log, then we're going to have our quotes, and we want to say something in here. So for example, if we look at this, we can see that if age is greater than 16. Okay, so if my age is greater than 16, I want to print out something. So for our example, we were saying about if people were, you know, greater than 16, they would be able to work. Okay, so we want to put in quotes here, eligible. So let's say eligible to work. Okay, and there's actually a slight little problem here, okay, but I'll get back to that now in 1 second. So I'm going to go and run this, and we can see that eligible to work is printed out. That's because we've set our age here to 25. Now imagine if we set our age to something else. So maybe we set our age to 12, and we go and run this program. We can see that we see nothing at all. So basically we try and see if this is true, this statement, age is less than 16, and if this is not true, it's just kind of skipped. We go on to whatever code is down underneath it now. In this example, we have no other code. This is the only thing that we have in our program, so nothing gets displayed out here. But there's a slight bug here. Okay, so imagine I was 16. So if you're 16, you're allowed work. So if I go and run this, you'll see that I don't get a message saying that I'm eligible to work. So realistically, this age should be greater than 15, assuming that our age can't be like, you know, 15.5, because just because you're 15 and a half, you're still not eligible to work. So it's important little things like this to understand and to get right. So if we go and run this now, we can see we are eligible to work. But again, using this example, we could have an age, let's say if someone was 15.5, so let's say they're 15 and a half, and we go and run this, we can see that they're eligible to work. But this shouldn't actually be the output. If you're 15 and a half, you shouldn't be able to work. So one thing that we could do is we could say if your age is greater than or equal to 16. So if we replace this with 16 and we go and run this again, we can see that nothing gets displayed out. And if we change this back to 16, we should get our outcome as eligible to work. And we do. We see eligible to work. So that's just like little things like that when you're programming your own individual programs, to just keep in mind that your conditional statements are correct, and think about different inputs that you could get and how that might affect it. Like imagine what if we put in, let's say, a string in here, right? So let's say you know, for some reason we're supposed to be getting in an integer, right? So we're supposed to be getting in a number. Imagine we got in Ryan. If we go and run this, what happens? We don't get any result. So that's what we would expect to see. So that's good. But this is part of testing your own programs, you know, testing different variables, testing different numbers and seeing what happens and making sure, or trying to minimize the amount of problems that your programs will have. So I'm just going to go through one more really quick example. So we're going to get rid of age here and we're going to replace this with name. And in actual fact, I'm going to delete all this just to avoid confusion. And I'm going to say let. So let, and I'm going to say name, and I'm going to set my name to Ryan. So I'm going to put Ryan like this. And now I'm not checking for age anymore because age has been deleted. So I'm going to be checking for name. And I want to check my name for something. And I want to check to see, is my name equal to Ryan? Okay. So remember, if we want to check, we use 2 equals rather than 1. And we can even use 3 if we want to compare it, both type and content. So we covered this in some of the previous videos. So if you're a little bit unfamiliar with some of these things, go back and take a look at the previous videos. Because in these videos, from this video onwards, you know, we're going to be building on the things that we've learned prior to this. So we're just going to put in our string here, and we're going to put in Ryan. And we want to check this, and we want to say, right, okay, so we don't want this eligible to work anymore. We want to change this because this is, you know, seeing if somebody's name is Ryan. So we might say, hi Ryan. So if we go and run this, we can say we get our message displayed, hi Ryan. But imagine if I put a different name in here. Imagine if I put in Chris, right? Okay, so let's run this, and we see no output, which is perfect because that's what we want from our program. We haven't made our program deal with the name Chris or any other names at all. And that's what we're going to get into in our next video. Our next video is going to be talking about conditional statements also. We're going to be using if statements, but then we're also going to be using this other statement called an else statement. And it's also a keyword, and it's actually really useful when we go and create programs. Hello everyone, in this video we're going to talk about conditional statements. Now, in the previous video we talked about conditional statements using the if keyword. So in this video we're going to talk more about conditional statements, and we're going to use the if keyword, but we're also going to use another keyword called else. So we're going to use 2 conditional statements in this video. Now we're going to use a similar example to our previous video just to keep things simple. So we're going to start off by creating an age variable. So let age, we're going to set it to 25. So for this example, we want to check to see if somebody is eligible to work. So we want to see if they are greater than the age of 16. So if you remember from our previous video, we would use our if statement here, and inside our if statement we would take our variable, so our variable is age. We would then use the greater than sign and then compare it to some value. And we're using 16 here because 16 is the legal working age in Ireland. Then we move into using our curly brackets, and we could bring this curly bracket down to the next line, or we could just leave it after our round bracket here. I prefer to leave it after the round bracket. You can do whatever you want, whichever is, you know, more readable, or whatever way you're able to understand the code yourself. It's personal preference. So within this then, we used a console log, and we logged out whatever. So you can put anything in here. Our console log in this example is just really a check to see, has the condition been met or has it not been met. So we would put something like eligible to work or something like that as our console log. Eligible to work. Now if we go and run this, we are going to get our output as eligible to work. So we're going to see the text eligible to work. But imagine we weren't eligible to work. So in our last example, if we were 12 and we went and ran this program, we would see nothing. Okay, so that's okay, but we can, you know, we can make this a lot better. So if we put this back to 25 because that's our age, And after this second curly bracket, we can use another keyword called else. So we can have else, and then after else, we're going to have another two curly brackets. And within these curly brackets, an action that will happen if this first conditional statement is false. So for example, let's say the age is less than 16. This won't be printed out, because we've seen that when we put in our age as 12. But if we have an else statement, this will be then executed. So if I put in something like this, maybe console.log. Now if I go and run this program again, I'm going to see eligible to work because I changed my age back to 25. But if I change this to 12, which I had before, my output was just nothing. It was blank. This debug console here had no text in it whatsoever. But if I go and run this now, since I put this else statement in there, we'll see the text not eligible to work. So I'm going to go and run this now, and we can see not eligible to work. Now this here, the way it's structured, it works fine. I prefer to clean it up a little bit more. So I almost prefer to get my first curly bracket and leave it on the same line as my conditional statement. So you can see with my if here, I have my curly brace just after the second round bracket, and with my else statement, I have it on the same line. Then I also on the following line have whatever I want to do, and then I close it on the following line. So if I just tidy this up here, this is the way that I like to code. This is the way that I think it looks nice, and I can read it much easier. There's some people that would rather have it maybe like this. You could also have it like this if you wanted to. You can have it any way you want. Once the content is within these curly brackets, and you open and close your curly bracket before you open your else statement. Like for example, if we go and run this now, we can see we get the exact same output. So it's just a little bit of personal preference and whatever you feel is the most readable for you. When you're starting off, you probably don't really care too much once your program's working, but as you work on your programs more and more, you'll find that when you go over something and you read over your code and you try and implement new things and play around with stuff, you try and keep your code so that it all looks the one way rather than just it all being different. So in my previous video, I went through a second example with a name. So I'm going to go through a similar example here. So I'm going to get rid of all this. I'm going to start from scratch because I think that's always a good way, get rid of all your code and start writing from scratch. It sort of trains your mind to not just be deleting variables and filling new ones in. If you go and have to start from scratch, I feel that it's a better way of learning how to program. So we're going to start off again. We're going to create a variable this time. We're going to call it name, and in name we're going to put our string of characters, which is going to be Ryan. So let's jump into it. So let name equals Ryan. So now what we want to do is we want to go and check to see if this variable name is Ryan. Okay, so we have if, and within this we're going to use our name variable, so name. And last time we were checking for if the age was greater than. Now in this we're using a different operator. We're using a comparison operator. So we use our double equals. We could also use triple equals in this case, but for this example we're just going to go with double equals because it'll be good enough. And now we want to put in what we're looking for, or what we want to compare it to. So we're going to compare it to Ryan. So we place in Ryan, and then we put our curly brackets. So we want to say something. If our name is indeed equal to Ryan, we want to print out something. Console.log. And within our console.log, we'll just say something like, hello, Ryan. Now, since we've learned about our if statement, we want to print out something else if your name is not Ryan, okay? So let's say we have something like this. So we're going to use our if statement with our curly brackets, and we're going to console.log something else. So within this else statement, we're going to console log I don't know you. So now we can see that our variable is set to Ryan. So if we go and run this now, we'll see that we get our output as hello Ryan. But imagine we used a different name. Imagine we used something like Chris, okay? If we go and run this, we'll see I don't know you. So we can't check to see if our name is Ryan or Chris. What we could do is we could say something like this. We could have name equals Ryan, and we could use our AND operators like this, and we could say name equals and then the word Chris. But then the problem we run into here is if our name is equal to Chris, we're going to console log hello Ryan. So it doesn't really make much sense. So we'll see one way that we can get around this in the next video, and it's actually using an else if statement. So in the previous video we used if statements. In this video we used else statements. In the next video we're going to use if statements, else statements and else if statements. And hopefully you'll be able to get an idea of how they can all be used to create our programs. Hello everyone, in this video we're going to be talking about conditional statements. Now, we've talked about conditional statements before. In our previous couple of videos we talked about our if statement and our else statement. In this video we're going to be using our if and else statements, but we're also going to be using another statement called an else if statement. So if I jump into it, I'll create a new file and I'll call my file conditional statements else if. So if we go and open this up now, if you remember to our previous video when we had a variable, so we had a name and we originally set our name to Ryan. We wanted to check to see if Ryan was in fact the name, and if it wasn't, then we just printed out I don't know you. So we can recreate this again with our conditional else if statement, but this time we're going to put an additional check in there, because if you remember in our last video when we changed our name to Chris, we didn't know about Chris, so we would print out I don't know you. If we put in Amy or if we put in Chloe, we'd still get the same exact output, which would be I don't know you. So let's recreate this really quickly. So we're going to start off, we have our let, we're going to have our name variable and we're going to set that to Ryan. Now we want to check to see if the variable name is in fact Ryan, so we're going to say name with two equals, and then we're going to put in quotes our name, creating our curly brackets and doing a console.log, and for the message we'll just say hello Ryan. Now if we add an else onto this, so we just use the keyword else along with two curly brackets, and we can console log I don't know you. So this was the program that we had in our last video. So if I go and run this now, we can see we get hello Ryan. But if we had a different name, maybe let's say we had Chris, and we go to run this, we'd see I don't know you, which is fair enough because that's exactly how we've programmed our solution. Now what we're going to do is we're going to add in an else if, and an else if is just like an additional check to see if something is true. We will bring our else down here, and rather than putting an else straight after our if, we're going to have an else if. So else if, and we're going to have some condition inside our brackets. So it's quite similar to our else. The only thing that will be affected is the flow of the program. So as we step through the programs, as the computer reads it line by line, it'll be checking to see if our name variable is equal to Ryan. If it's not, it'll move on to our else if, and if our else if is also false, so whatever statement we put in here, let's say we put in name equals to Chloe, and Chloe isn't the name, it'll go and print out I don't know you. But for this example, we're going to put in Chris as our name. So we can have name and double equals, and now we're going to put in our name Chris. So what will happen now is, since our name is set to Chris, we want to print out something inside this else if statement. And what we want to do is we want to greet Chris. So we want to console log hello Chris. So by looking at this program now, we can see that if our name is equal to Chris, we'll print out hello Chris. So we just tidy this up a little bit. We can bring our else up here, I just feel it looks a little bit neater. And when we run this now, we should see Hello Chris displayed. So I'm going to run this and see our output, and we can see Hello Chris. And if we change this back to maybe Ryan, and then we go and run this, we can see we get Hello Ryan. And then if we put in a different name in here, maybe we put in Amy, and we want to run this, we see I don't know you, because the program that we've created here is only aware of two different people. And the two different people that it's aware of is Ryan and Chris. So it does a check for those two people, or we know them as people, but they're just actually strings as far as the computer's concerned. You know, it just sees this string as RYAN, and it sees this second string as KRIS. And our else if isn't limited to just using one. So we could have, let's say, maybe another else if. So let's just bring our else down to the next line here, and we want to do another else if. So we want to check for another name. So maybe we want to check for Amy. So we'll say else if our two brackets. Now we're going to put our condition inside. So we'll have name with a double equals and our name Amy. So if we go and strip through this now, we should find that if we have Amy set as our name, we will execute whatever code will be inside these curly brackets. So similar to the other two conditional statements, inside this one we're just going to put a console log and greet Amy. So now if we go and run this, we can see that we get hello Amy, while when we run this before, the computer didn't know that Amy existed, or it didn't have a check to see if our name variable was in fact Amy. So now, depending on what we set our name to, if we set our name to Ryan, it'll greet us as Ryan. If we set it to Chris, it'll greet us as Chris. Or if we set it to Amy, it'll greet us as Amy. But keep in mind, if there's some name that we're not familiar with, or there's some name that we haven't programmed into our computer, so if we use maybe the example Chloe, so if we go and search for Chloe, or we go and run this program with Chloe as our name variable, we can see that we get a I don't know you message, and that's because we haven't programmed Chloe into our if or our else if statements. You could do multiple if statements and multiple if else statements, but there's actually something else you can use, and it's pretty handy, and it's called a switch statement, and it's much cleaner and it's much easier to understand. So in our next video, that's what we'll be going through. Hello everyone, and welcome to this video. Today we're going to be talking about switch statements. Now in our previous video we've covered different types of conditional statements such as if, else and else if. Now the reason why I'm introducing you to a switch statement is because it's an alternative way to program rather than using multiple if statements or multiple if else statements or using multiple else if statements. So if you have a quick look at this, you can see this is our program that we created in our previous video. It checks for 3 different users, and then it provides a message if none of the people's names are met. So we're going to start off by creating our new file, and we're going to call it switch.js. We're going to go through the same example we had in our previous video, but this time we're going to create a switch statement. So it's going to be using the exact same values and variables. So we're going to use Ryan, Chris, Amy and Chloe, but we're going to show you how to do it using a switch statement. So to do this, we're going to start off with declaring our variable name like we have done in our previous video. So we're going to say var name, and we're just going to set it to Ryan initially. So equals and Ryan. Now what we want to do is we're going to use the switch keyword. Now you're familiar with the if keyword, the else keyword and the else if keyword. So this is just another keyword that we can use in JavaScript. After our switch keyword, we're going to place 2 round brackets and we're going to put whatever we want to check. So for this example, we want to check our name. So we're just going to put our name variable inside our switch statement, and then we're going to open up our switch statement similar to how we would open up an if statement or an else statement. So we can do this by doing 2 curly brackets. And I'm going to bring that second curly bracket down to the next line, And what we're going to do now is we want to check to see what our name is, and we're going to check a couple of different inputs. So if we go back to our previous video and our previous file, we can see that we checked for Ryan first, then we checked for Chris, and then we checked for Amy, and Chloe was a default. So Chloe wasn't actually checked, so if we put in our name as Chloe, or we put in our name as James or any other name, we would get this standard message, which is I don't know you. So we're going to be doing something similar with our switch statement. So we want to check to see if our name is Ryan, and how we do this is we say case, and after our case we put in whatever value we want to check. So we want to check to see is the name variable, which we've declared inside our switch statement, we want to see is that in fact Ryan. So we can check that by putting in the string Ryan, and after Ryan we're going to put a colon. Now, not a semicolon, a colon, and you'll be able to find the colon. It's just to the right of the L letter on your keyboard, but if you just hit that you'll get a semicolon, which will look like this. I know there's a very slight difference, but your computer won't work if you use a semicolon. So you have to just use a normal colon, and how you do this is you hold down the shift button and then you press that semicolon, and it'll give you one that looks like this. You'll notice a colon is just like two dots, while a semicolon is like a dot and a comma. It looks like this. You can see that it's a dot and comma. Now, if our name is Ryan, we want to do something, okay? So we're going to move down to the next line and we're going to console log hello Ryan. So we can now see if our name is Ryan, hello Ryan should be displayed. So we're going to run this and see what we get, and we can see we get our output as hello Ryan. Now we want to do some other checks. So we want to check for the name Chris, and we want to check for Amy, and we're going to use Chloe as our default value, but we could use anything that's not included in these three examples. So we're going to move on to our next line, and we're going to just go in one and we're going to say case again. So case is just like checking for a value. It's like using an if statement, but it's much easier to write. It requires less code. So we're going to say case, and now we're going to put in Chris. And after we have put in our variable Chris, or our string Chris, we want to put in a colon. So after we've put in our string Chris, we want to put in a colon, and then we move on to the next line. This next line will be what's executed when Chris is the name variable. So again, we just want to console log hello Chris. So now that we've got this, we want to do a third check, which will be a third case statement, and our value will be Amy. We want to check to see if our variable is Amy. So we're going to go to the next line again, like we've done with all our other examples, and we're going to console log hello Amy. And you can see that I've forgotten my colon here, so it's very easy to forget these little things. So make sure you have a colon after all your different statements that you're checking. Now let's assume we run this program now. So let's run it again, and we can see hello Ryan, hello Chris, hello Amy. So this doesn't make much sense because our name is Ryan, so it says hello Ryan to us, and then it says hello Chris, and then it has hello Amy, which doesn't look good. So what we can actually do is we can put a break statement in here. So if our value is Ryan, it'll go in here, it'll console log hello Ryan, and then it'll break out, so it won't bother performing any of these other checks. So we're going to go and run this again, and if we run this again, we can see hello Ryan. And imagine we were to change our name from Ryan to maybe Chris. What would happen now is Ryan would no longer be true, so hello Ryan would not run, and then we would check for Chris here, and hello Chris would run, but then Amy would also run. So let's just run this and I'll show you what happens. And you can see we get hello Chris and hello Amy. So again, we want to put a break statement on the following line for Chris, so we want to say break, and we'll do the same for Amy. So now if we go and run this program again, we can see that hello Chris is displayed when Chris is the value. We can see Ryan was displayed when Ryan was the value, and we'll put in Amy. We just test Amy, and we can see hello Amy. But imagine if we put in something like Chloe. So we could put in Chloe, and if we go and run this, we can see that we get nothing as our output, which is exactly how we've programmed our solution, because we've checked for Ryan, we've checked for Chris, we've checked for Amy, but we've no else statement. Like here, if none of these were true, we printed out I don't know you. So with a switch statement, we can do something similar, but it's not called a case, we'd call this a default. So we just use the default keyword followed by a colon, and then on the next line we will do whatever we want to do when Amy or Chris or Ryan is not the value. So I'm just going to print out the same thing that we done for our previous program, I don't know you. So now if we go and run this using the variable Chloe, we'll see that we get I don't know you. And if we were to put in maybe a different name here, maybe we were to put in James, let's say, and we want to go and run this. So using a switch statement over an if-else statement can be really useful if you've got multiple inputs. Rather than having to check them all using loads and loads of if-else statements, you can use a switch statement instead. Hello everyone, in this video we're going to talk about loops. Now there's three different types of loops that we're going to cover. First of all, we have a for loop, we have a do while loop, and we have a while loop. In this video we're going to be covering the while loop because it's probably the easiest loop to understand, so it's the best one for us to get started with. We've covered conditional statements and operators before. These loops that we use will combine our knowledge of our conditional statements and our operators from our previous videos, but we'll be able to bring them all together to allow our JavaScript programs to do something a little bit more useful than a simple example. Now for this video we'll be going through simple examples with for loops, but you should be able to start coming up with ideas and ways of how you can bring all these together to create some useful application. So I'm going to start off by creating a new file, and I'm going to call my file whileloop.js. In this video we're going to be using our while loop to go over some task or get the computer to perform some operation multiple times. So for example, if we wanted to print out the message hello Ryan or hello world or any message at all, traditionally what we'd have to do is we'd have to write that code however many times we wanted to. So for example, let's say we wanted to write hello to our console window down here 3 times. We would have to write console.log hello. So you can see that I wrote console.log hello once here, and if I go and run this we can see hello. If I want to perform this operation 3 times, I would have to write the code 3 times like this, and if I go and run it we can see that we get our output as hello, hello, hello. Now this is a simple example, but we can actually use while loops or loops in general to semi-automate this process. So let's say for example I wanted to change that message from hello to hello Ryan. I would have to change that in this string, I'd have to change it in this string and this string. So with loops we can have it in one central location, so we only have to change it in one place and it'll be effective throughout the rest of our program. So let's jump into an example of a while loop which might help you understand what we're going to do here. Now before we start using our while loop, we're going to use this concept of a counter, and a counter is just going to keep count, like the name suggests, of what stage we're at. Okay, so we could have a counter and we'll set the counter to 0 because when we start something we usually start at 0. And there's something that we want to get to. So for my example, I wanted to print out the number 3 times. So I'm going to have some variable containing the number 3. So I'm going to just say num equals 3 because in this case I want to print it out 3 times. Now to make sure that we're carrying out proper JavaScript syntax, we can put the keywords let or const before our variables. So I'm just going to put let. It doesn't actually matter for this example if you choose let or const. So now we get into the interesting part, and that's the actual while loop. So similar to like our if statements or any of those, you remember me saying that we have keywords. So with our loops it's something similar. So we have another keyword, and this keyword for this particular while loop is called while. So if we type while, and then we want to put two round brackets, similar to our if statement, and we want to put a condition in here. The condition that we want to check would be to see if our counter is 3, because if our counter is 3, we no longer want to loop through or repeat the same task. So if I said while the counter is less than num, so this is basically the same as me saying while 0 is less than num, which is 3, so while 0 is less than 3, and what's going to happen is we're going to increment our counter. So by increment I mean we're going to add 1 to it. So then the next time when we go and check this, it'll be is 1 less than num, and then I'm going to increment it again and it's going to be is 2 less than num, and then we're going to get to a stage where we're going to check to see if 3 is less than num, and 3 isn't actually less than num, so 3 isn't less than 3, it's equal to 3. So what would happen then is we would no longer go into our while loop and we would finish our program. So as you can see, there's a red squiggly line here at the second bracket, so that usually means that we're missing something. So we're missing our curly brackets. So I'll put 2 of those in there, and we'll just bring that on to the next line to make it a little bit clearer. And now we want to perform our operations. What we actually want to see or let our program do will go inside these curly brackets. So I'm just going to console log hello. So now we want to run this and see what output we get. We're not actually going to get our desired output because we've forgotten to do one thing, but I just want to show you this. So we're going to run this, and you can see that we see a lot of hellos, and these are actually continuously generating new hellos. So we're going to stop this program here, and I'm going to explain exactly what happened. So what happened here was our counter was equal to 0. So we were checking to see if 0 is less than num. So is 0 less than 3? So that's true. So we go inside our while loop and we console log the message hello. And then after we've console logged our message hello, we go back up to this while loop again and we check to see if our counter is less than num. So our counter is still 0. So is 0 less than 3, which is num? It is. So we go back inside this while block and we print out the message hello. And this keeps happening because counter is always 0. What we need to do inside our while block is to increment our counter, so to add 1 to our counter. Otherwise this program is going to go on forever. It's never going to end, and it's just going to keep printing out hello all the time. And you can see there's many lines of code that just says hello, and that's not what we wanted. We wanted to just see hello 3 times. So we're going to go and increment our counter. So on the following line after our console log, we're just going to state counter, and on the following line we're going to just write counter plus plus, and counter plus plus is just a shorthand way of adding 1 to the counter. You'd have learnt this in some of the previous videos. You could also do counter equals counter plus 1, and this would give you the exact same output and the same result, but I just think it's a little bit cleaner if we use counter plus plus. It saves us typing out a little bit of code, and I think it looks neater. So if we go and run this again, we'll see that we get hello displayed out 3 times. I'd suggest that you play around with this program a little bit. So maybe you want to put in a different message. So we know that we can put anything we want in here. This is just displaying out a message. So we could say hello Ryan 3 times. We could also say maybe the variable in here. So rather than displaying out a message like hello or hello Ryan, we could actually display out the counter itself, so we could see what exactly is going on. So if we go and run this, we can see the numbers 0, 1 and 2. So by doing this we can see that first of all our counter is 0 and it's printing out 0. Then 1 is added to it, so then when we go in here our counter is printed out as 1. Another 1 is added to it, it's printed out as 2. Then when another 1 is added to it and our counter is 3, it doesn't actually go inside this loop. So the counter does get to the number 3, but it's never executed inside this loop while the counter is equal to 3. And you can change these numbers around. So maybe we don't want to use num, maybe we just want to use the number 3. So we're going to get the exact same result here, but just know that you can use numbers in here. And if we're using 3 there instead of num, we don't actually need the variable num, so we could actually delete that. And we can run that again and you'll see exact same result. We need to keep our counter because we need something to be able to increment and keep track of our program and to know when we want to finish executing. Hello everyone, in this video we're going to cover do-while loops. So in our previous video we covered while loops. Now these do-while loops that we're going to cover are very similar to our while loops. The only difference is we use a slightly different syntax, so we use a do keyword, and if you're using a while loop, if your condition is not true, your block of code inside your while loop will never execute. But if you use a do while loop, you're guaranteed for it to execute at least once. So I'm going to jump into an example and hopefully it'll make a little bit more sense. We're going to start off by creating our JavaScript file. I'm going to call mine dowhileloop.js, and within this loop we're going to have something similar to our previous video where we had a counter and we had some value that we wanted to compare it to. So for this example we'll use a counter as well. So we'll say let counter, and we'll set the counter to 0, and we'll set our number to 3. So similar to our last video, we have a counter set to 0 and we have a num set to 3. Now what we want to do is we want to declare or define what's going to be executed. So for this example we're going to do something similar to our previous video where we printed out hello. So we're going to do the same this time, but we're going to use the do keyword. So last time we had our while statement, we had a condition, and then we had our curly brackets with our code that would execute. This is just slightly different. We're going to use our do keyword followed by 2 curly brackets, and now inside these curly brackets we're going to write our code that we want to be executed. So for our example we're just going to do a console log hello. So you can see there's another little bit to this program because we've got a red squiggly line, and the next bit that we have to do is we have to specify when do we want this to happen. So as I said in the previous video, with our while loop we had a condition, so we're going to have the exact same thing here. We're going to use the while keyword. We'll also have a condition. So our condition would be while our counter is less than num. So counter is less than num. So what's going to happen now is our do, or whatever is contained in our do, so in this case console.log hello, will be printed out every single time that our counter is less than num. Now we're going to have a problem here. It's going to be similar to our previous video, but I'm going to run this just to see what we get. And again, similar to last time, if you remember, we got a lot of hellos printed out, and the reason for this, we forgot to increment our counter. So you can see there's a bunch of hellos printed out to the screen here. We only wanted to see 3 because we set our number here to 3. So we need to go and increment our counter. So that's actually done inside our do. Remember, with our while loop in our previous video, if I just go to the example, we had a while loop, we had our condition, which was counter is less than 3, and whatever code we wanted to execute. But in our do while loop, the do is always called first, and then it checks it. And you might be wondering, why would you go and execute some code and then check to see if it's true or if it meets the condition? You do this in cases where you want to execute the code at least once, and then you want to go and check it and see does it need to be executed a second time or a third time or a fourth time. If you use a while loop, this would be something that you want to check for the condition before you execute any code. We need to go back to our do while loop and we want to increment our counter because we don't want to see multiple hello worlds. So we're going to go back to our do while loop and we want to increment our counter because we don't want to see multiple hellos displayed to the screen. We only want to see 3. So this is the outcome that we wanted. And again, you can play around with this. So imagine we set our counter to 30. So in this example, our counter is always going to be bigger than our number. So if we go and run this, we can see that we get hello displayed once. And the execution of our program is that it goes into our do block, it performs whatever's in there, and then it goes and does the check afterwards to see if the do loop has to be executed a second or third time. So maybe we want to try something different. Maybe we want to count from the number 1 to 10. So if we want to do this, we would set our counter from 0 to 1, because that's our starting point. That's the number that we want to print out first. And we'd set our num here, that represents how far we want to go up to. We'd put 10 in for this. And then if we go and print this as it is, we'll see what output we get. So we see a few different hellos. So if we go and count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our program only displays hello 9 times. And this is because when our while loop is executed, when the counter is 10, the counter is not actually less than the number. So if we wanted to do this, or we wanted to get 10 hellos as our output, we would need to change this 10 to an 11. So we can change that back to 10. And if we go down to our while loop, we can say if the counter is less than or equal to the number. And if we go and run this, we can see the output is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hellos. So that's what we wanted. But maybe we don't want to say hello 10 times. We said we wanted to count up the numbers from 1 to 10. So rather than console logging the message hello, maybe we can print out the counter, because the counter is going from 1 to 10. So if we put in counter here, and now we run our program, we can see the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is one simple use case for our do while loops. In the next video, we'll talk about our final loop that we're going to cover, which is our for loop, and it's probably one of the most popular loops that you'll use while you're programming. Hello everyone, in this video we're going to cover our final loop, which is our for loop. It's probably one of the most popular loops that you'll use while you're programming. So with a for loop, it takes in how many times you want to loop through a certain set of conditions, and there's an incrementer built into the condition statement. So a for loop is really useful if you know how many times you're going to be wanting to perform an operation, while a while loop or a do while loop is more used if you're not quite sure on how many times you'll have to iterate or perform a list of operations. So let's jump into it with a quick example. So I'll create my file, I'll call it forloop.js. We're going to print out hello, similar to what we've done in our previous 2 programs using our loops. So we'll start off with the keyword for. And again, you're probably getting used to this. We're using our keyword for our for loop. We're using 2 round brackets. And in our previous videos, you've seen that we've put in a condition inside our loop. So for our while and our do while loops, we had some condition that had to be met. So in a similar way, we're doing the same thing with our for loops. Now we need to start off with an incrementer. So previously you've seen me defining my incrementer outside the for loop or outside the while loop. We could actually define it inside our for loop. So we could say let, and we usually call our incrementer I. I is just the first letter in the word incrementer, so it kind of makes sense. And we want to set it to 0 because we want to start at 0. Now after we've put down 0, we want to put in a semicolon. So we put down a semicolon, and now we want to define how many times we want to iterate, or how many times we want to go through and perform these list of instructions. So in our case, how many times do we want to go and print out hello world? So we want to define while I is less than some number. So the number that we'll use in this case is 5, while I is less than 5, we want to print out hello. And the problem that you've seen in our last 2 loops was we ran into an infinite loop, or we got a bunch of hellos displayed out to the screen when we didn't want them. So we want to increment with our for loop as well. So we put down another semicolon and we put down an I++. So this is pretty neat and compact. Put down 2 curly brackets. We're going to bring that down to the next line, and inside these curly brackets, similar to our other for loops, we're going to do our console log hello. If we go and run our program now to see our output, we can see that we get 1, 2, 3, 4, 5 hellos displayed to the screen. Now, similar to our last video, what we can do is, rather than saying hello, we could do something like this. We could put in I here. So I is our counter. And if we go and run this here, we can see we count from 0 to 4. And just because our incrementer is set to 0, this is usually what we do because we want to start counting at 0 and work our way up to whatever our number is. So if we have maybe 10 elements or 10 names that we want to display, we might use a for loop to count up to the number 10. But this incrementer could be set to whatever, like it could be set to the number 3. The only thing to keep in mind is if this is set to 3, it's only going to print out our numbers in this case. It's only going to print out those numbers 3 and 4 because we're going to get to our number 5 much quicker. So if I go and run this, you'll see that we see the output 3 and 4. Now, we could increase this again if we change this. So this is currently 5, but if we put this to 15, we'd be able to count, or we'd get the numbers displayed out from 3 to 14, because again 15, the number that we say here, isn't actually counted or isn't actually displayed, because when our incrementer checks to see if 15 is less than 15, it's not actually less, so it skips the for loop. So I'm just going to run this, and you can see we start off with our number 3 and we finish off with our number 14 being displayed.
Hello everyone, in this video we're going to discuss JavaScript objects. Now, JavaScript objects are a type of data structure that we can use in JavaScript. So similar to arrays in our previous video, we talked about how arrays can be used and how data can be added to it, rather than just using a single variable to hold one data type, like an integer or a string. We could use a variable to hold multiple data types and multiple different values. Now, what we're going to be discussing in this video will be objects, and they do something similar, but they're structured slightly different. So let's start off by creating our file. I'm going to call it objects.js. And now, if we go and just look at our arrays, we can see that we started off with using let ages, and we set this equal to an array. So I'm just going to copy this into my objects file, just so you can compare the two of them together. So I'm just going to bring this down a couple of lines, and we're going to do something similar for our objects. So we're going to say let, and then we're also going to set it a variable name, and I'm going to call this variable myInfo, and I'm going to set the variable myInfo to 2 sets of curly brackets. So in the last video for our arrays, we used these square brackets, but in this video we're going to use curly brackets. So you need to hold down the shift button on your keyboard and then hit the opening round curly bracket and the closing curly bracket. And similar to the square brackets in our array, all the information that we're going to use is going to go inside these curly brackets. Now, unlike arrays, we just added many different values. As you can see here, we had an age of 25, then we had another age, then we had a second age and a third age and a fourth age, and so on and so on. But with objects, we actually use this idea of a key and a value. So imagine this key, and then we put a colon, and then we use a value. Now, this isn't actual syntax, but this is just here to try and illustrate what I'm talking about. So a key could be anything, right? So a key is just like another variable inside our data structure. So for example, a key could be first name, last name, age, and then the value might be Ryan, Hill,
25. Okay, so we're going to start off by creating a key, and that's the example that we're going to go with. We're going to start off by creating our first key, and we want to set this first name to a variable. So the variable that we're going to set it to will be a string, and that string will be Ryan. Now, normally when we want to set a value to a string or an integer, we use this equal sign, but we don't use this equal sign when we're using objects or array objects. So what we use instead is this colon. So similar up here, we have our key, we have our colon and our value, and here we have our key, then we have our colon, and then we have a value. Now we want to add a second key value pair. We call these pairs because for every key we have a value that's associated with it. So we want to put our comma here, and now we want to put last name. So we'll type in last name here, followed by a colon, and then we want to go and use a string, and we're going to set this string to Hill. Now again, after this we're going to put another colon because we want to add another key value pair, and this key is going to be called age, and we're going to set this to the age of 25. Now this is the last key value pair that we're going to use for this variable here. Remember, the variable that's going to store all this information here will be called myInfo. So when we've reached our last key value, we don't have to add a colon here. Now I'm going to get rid of this key colon value because this isn't actually valid syntax. The compiler will actually complain to us and the code will not work if we keep this in here. This was just put here to try and help you understand what each of these keys and values were. So I'm going to get rid of this, and I'm going to also get rid of this here because we don't need this because this is an array. And now we're going to console log myInfo. Okay, so I'm going to keep the console log, but I'm going to get rid of the ages. So now I'm going to type in myInfo, and now if I go and run this, I can see that I get these curly brackets with first name Ryan, last name Hill, age 25, and it's all together on one line here. Now when I define this, I put them all on separate lines, but you could do this. You could keep them all on the one line, and this is acceptable as well. So let's go and run this again, and you can see we get the exact same output. I just feel, from my point of view, that it's more readable for me as a developer if I put each of these key value pairs on different lines. It's easier for me to go back to my code and see exactly what has been set to first name and what has been set to last name. But you can have it all on one line if you wish. So similar to our arrays, we were able to pick out one element in the array and just print that. We can actually do something similar with objects, but in arrays we use these square brackets. We don't do this using objects, we actually use the dot. So place a dot after myInfo, and then you can see we've got some options here. Okay, so let's go and select ages. So I'm going to select age, and then I'm going to go and run my program again, and now you can see we only get 25 being displayed here. So this is great, and you can also take age away and you could put maybe first name instead, and we can go and run this and we can see now only Ryan is displayed. So just keep in mind, we're going to set our key value pairs. Our key can be whatever name we want, and our value can be whatever value we want. It can be integer, can be a string, could be a float or a decimal number, whatever we want. And we can access different parts of the object by using the dot followed by the key that we want to display. Hello everyone, in this video we're going to be going through arrays. Now in our last video we went through our third and final video on loops. which was the for loop. But today we're going to be covering something a little bit different. So you would have seen us creating variables before and setting them to an integer or a string. Now, an integer or a string, we can refer to these as data types, but there's also something else we can create, and they're called data structures. And similar to an integer or a string being a data type, an array is a type of data structure. So I'm just going to start off by calling my file array.js, and we're going to go through a really basic, simple example of how we can use arrays. So similar to how we would define a normal variable, we define it by saying either let or const, and then we pick a name. So we could call it nums or num. I'm going to set it to num for now, and I'm just going to set it to a normal number. So this isn't anything got to do with arrays just yet. This is just me setting this num to a normal number. And I'm going to console log our num variable, and I'm just going to go and print it out. And when I run this, we can see that we get the number 9 displayed out here. So this should be something that we're very familiar with and comfortable with at the moment. So now I'm going to change this into an array. And an array uses square brackets, and we can find the square brackets on our keyboard over on the right hand side, close to or just above the enter key. Now, if we want to use these square brackets, we want to put them after our equal sign. So in this example, I'm going to get rid of the number 9, and I'm going to put in 2 square brackets. Now, within these square brackets, we can populate our data structure with many different data types. So for example, let's say before, if we wanted to, collect the ages of a couple of different people, we would have to create a variable and call it maybe age 1, and then possibly another age 2 variable, and then we would place the 2 numbers into these variables. But with an array, we can put these together. So let's say we put the age 24 and 25 into our array. And just so there's no confusion, we can change our variable name from num to age because it makes a little bit more sense. And if we go and run this, we can now see 2 integers or 2 numbers being displayed out, and we can see they're held within these square brackets. So that's good. Let's add another couple of elements to our age array, and maybe we'll call this ages. We'll put an S at the end, and we'll put in some other ages in here. Okay, so now we've got a few more ages. Just put a space there, keep it consistent, and we're going to go and print out this again. So just run this, and we can see that the numbers that we have added to our array is printed out here. Now, arrays are really handy when you want to go and store a lot of information in the one variable. For example, you might have a list of ages. All these ages share something in common. So for example, this might be the ages of all the people in your house or something like that. So you could change this array to put whatever ages you want. You might want to represent the ages of all the people that live in your house, or maybe all the ages of the people that are in your school, or whatever you want to do. And let's say, for example, you wanted to access one of these numbers, right? So we know that we've got our ages variable here, and it's set to all these numbers. And we know that we're printing out, or we're console logging all the ages using this statement, but we can actually access one individual element if we want. And we can do this by putting 2 square brackets, and inside the square brackets we put what number we want, and this number we call an index. So let's say you could put maybe 1 or 2 or 3 here, and you would get 1, 2 or 3. Now, one thing you want to keep in mind is when we use arrays, let's say we put the number 1 in here and then we go and run this. We can see the number 24 being displayed. And you might be thinking, why is 24 being displayed when I put 1 in here? I want to see the first element or the first number in my array. Well, the thing about arrays is they're kind of funny in a way, because they don't actually start counting at the number 1 like we usually start counting at. They actually start counting at the number 0. So if you wanted the 5th element, let's say, so we go 1, 2, 3, 4, 5. So if you want this number here, which is 43, you would actually put in 4. So you'd put in 1 less than what you would want. And then if you go and run this, we can see that we get the number 43. And if you wanted to get the first element or the first number, you would put in the number 0 here. And if we run this, we can see now we get 25. And another thing to keep in mind, at the moment I've got all numbers in my array, but there's nothing stopping me from removing one of these numbers and replacing it with a string, or just adding a string to the end here. So for example, let's take away the 24 and let's put in a string, and we just put in our string as Ryan. And now we want to go and access the second element. So rather than putting 2, we have to take 1 away from it. So we put 1 in here, and now if we run this, we should see our second element, and our second element is Ryan. So if we go and run this, you can see that Ryan is displayed. Arrays are really useful, and they can be used for many different things. They're probably the most popular data structure that we use in computer science. We also have another data structure called an object that we can use as well, and I'll be discussing how we can use objects in the next video. Hey everyone, in this video we're going to talk about using functions in JavaScript. Now, in our last video we covered objects, and in the previous videos all the logic we used was executed. So for example, if we put in a console log hello or a console log name, or we created a variable and set it equal to something, that would definitely be run within our code. So for example, if we had a console log hello and then we had another console log which had world in it, hello world would be printed out. And there was no real way of us to decide whether a console log or a piece of functionality was going to be executed. If it was in the file, it was just executed, and that was that. But when we use functions, we can go and call a function under a certain circumstance. So that means we can decide on what we want to be executed in our program. So we have more control on what our programs can and cannot do. So let's start off by creating a new file, and we'll call this function.js. And I'm just going to go through a really super simple example just to demonstrate on what I was talking about when I was saying console log hello world had to be displayed. So we all know how to use console log. So I'm going to say console log, and within inside our console log, I'm going to say hello. Now I'm going to go and create a second console log, and I'm going to put world inside the console log statement. So now if we go and run this function.js, we can see that hello gets displayed and world gets displayed. So that makes sense. I'm pretty sure that's what we were all expecting. But if I wanted to only display hello, let's say, and I didn't want to display world unless something else was true or something else happened, how could I do that? Well, I could just get rid of this console log statement, but that means that hello will always be displayed and world will just never be displayed, or it won't be possible for console log world to be displayed. So one thing that we can do is use a function, and I'm just going to leave my console log world back in here, And when I mean I'm going to create a function, this function is going to contain some piece of functionality, and the piece of functionality in this example will be, it's just going to display out console.log world. Now in most functions they can be much more complex, but we're just going to keep it simple in this example. All our function is going to do is going to print out the word world. So to go and define a function, we have to use the function keyword. So we'll say function, and then after we use the function keyword, we have to create a name for it. And the reason why we have a name for all of our functions is because if we want to go and call that function, we need some way to reference it. So the same way that you have a name so that your teacher or that your parent or siblings can call you. Otherwise, how would you get somebody's attention if you didn't know their name? So a function works in the exact same way. It's just a way that we can go and call it to get it to execute something. So we're going to call this function say world, and we're just going to say world. So this is a bit of a strange name maybe, but this is the one that we're going to go with. And now we're going to have to put 2 round brackets after our function. And you might be wondering, what is the 2 round brackets for? And these round brackets take in things called parameters, but don't worry about parameters yet. We're going to cover them in another video, but just know that parameters are values that can be taken into a function. So we're just going to skip over that for now. Just know and remember that you have to put in a pair of round brackets after whatever your function name is, and then after your round brackets you need to put in a pair of curly brackets, and within inside these curly brackets will be what the function will actually do. So as we said before, we want our function to console log the string world. So I'm going to put that in here. And now I'm going to just delete this line here because we no longer want that. So this is our first function that we've created. It's pretty simple. Again, we use the function keyword, then we pick a name. Like this could be anything. You could call this my function, or you could call this function1, or you could even call this your name. You could call this Ryan. And then again, remember we have our round brackets. They take in parameters, but we're not taking any parameters in this function for this example, so we can just leave that blank. So it's just an opening and a closing round bracket. And then we move on to our curly brackets, and inside our curly brackets will be whatever functionality or whatever code we want to execute, and in this case it's console.log world, because world is what we want to display. So if I go and run this now, we're gonna get an output. It's probably not going to be the one that you might expect, but we're going to go and run it and let's see what we get. So when we run this, we see hello. Now you're probably expecting to see hello world, but we only see hello. And that's because we've created this function that's able to print out world, but it's not being displayed. So this hello world is similar to like maybe a student that has got an answer to a question that you can't get, right? So they've got the answer the same way that this function can print out world, but you haven't asked the other student for their answer, so you still don't know the answer. So in the same way here, we haven't asked the function to go and do anything. So if we want to go and get the function to go and actually do something, we need to tell the function we want you to do something. And we can do this by calling the function. And to call a function, we just simply say the function name, so say world, and we put in a round opening and closing bracket. And now when our computer sees this say world with an opening and a closing bracket, it'll actually call this say world function and it will execute whatever it contains. So if we go and run this again, we should see hello world. So we see exactly what we expect now. We see hello world. Now, as I said to you before, this function name could be anything. So like we could call it Ryan. And now remember, since we've changed our function name to Ryan, we also need to change what function we're calling, because if we go and run this as it is now, we'll see we get this error, and it's basically saying that, you know, we can't see or we can't find say world. You're asking us to call a say world function, but we can't find it. So we need to go and change this to Ryan, because the compiler is right. There's no say world function. It doesn't exist anymore because we've replaced it with Ryan. So if we go and run this again, we get the exact same output. So this is just a name. Again, this could be anything, but it's good to not just name your functions random things or random names. You want it to actually have a name that makes sense. So for example, if the function in this case is console logging the name world, having a function name like say world, or maybe a name like print world, something like that would make sense. But if we have a name like Ryan here, it doesn't really make much sense because we're calling a function called Ryan and Ryan's printing out world. That's just something to keep in mind as you're programming, because it can be quite easy to call functions certain names. Same thing with variables. You can call a variable a certain name, and as you're programming, you know exactly what that variable does, or you know exactly what that function does, and you're calling it. But when you come back to the code, maybe next week or maybe in a month's time, you don't really remember what that function does, and you kind of have to figure out again. So if your naming conventions are better for your variables and for your functions, it's much easier for you to understand your code when you come back to it in a couple of weeks' time. And it's also much easier for your teacher or maybe a classmate to understand what's going on in your code. Maybe if you need some help, or you're trying to show them your code and help them understand what you've done. But we've covered the basics of how to create a function. Now, in the next couple of videos, we're going to talk about the parameters and how we can send variables into a function, and how we can actually return values from a function, and how we can use that in our main function. And our main function is this bit up here, okay? So this is our main function. This is what's always executed. And then these other functions that we create, we can call these sub-functions. Hello everyone. In our last video, we covered functions. So we created a simple function and we called our function from our main function. Now, in this video, we're going to talk about using parameters. And parameters are variables that we have in our main function, and we can pass these parameters from our main function into one of our sub functions, and then we can go and use these parameters to create something, right? So a simple example for this might be, let's say in our main function here we declare two variables. Maybe we call them num1 and num2, and then we want to pass in num1 and num2 into a secondary function. So we want to pass our two variables into this function here, and then within this function we want to go and add these two variables together, and we want to just print it out. So we'll console log the sum of the two variables that we pass in. So let's start off by creating two variables. So we'll leave our console.log hello in here, just so we can see it being displayed out here in our console before anything happens. So after our console log hello gets displayed, we're going to initialize two variables, and we're going to say, let's call them num1, and let's set it equal to the number 5, and then we can say let, and we'll call this variable num2, and we'll set this equal to the number 6. We've got these two numbers num1, num2, and now we want to go and pass these two numbers into our function. Now our function at the moment is called Ryan, so let's go and call our function. So if you remember from last time, we say our function name followed by an opening and a closing round bracket, and we want to pass num1 and num2 in as variables. So we just simply get num1 and we paste it in here, and then we put a comma and then a space, and then we put num2 because that's the second number that we want to pass in. But let's go and run this for a minute, okay? Because this is not gonna work for us. So if we go and hit run, we get hello world being displayed, okay? So we're not really getting what we want. So if we look at this, we can see hello is being displayed and world's being displayed because we've called our Ryan function. But as far as our num1 and our num2, there's nothing really happening, right? We're not seeing num1, num2, or they're not being added, or nothing's really happening. So the problem with this is we're actually passing num1 and num2 into this function variable, into this function, which is Ryan, but this function is not printing this num1 or this num2 out. So maybe we want to try by doing that first. So I could say console.log, and then maybe I put in num1 here, okay? So let's go up and try and run this and see what we get. So now we get 5, right? Okay, so we're getting the number 5 displayed out, but what if I wanted to console log num1 plus num2? And I go and run this and see what output I get. So I get 11, which is the correct answer, but this is using num1 and num2. What if I wanted to shorten this when it's being passed into my function? So what if I said n1 and n2? So let's go and run this again, and I can see that I get 11 again, right? But what if I go and put n1 and n2 inside my console log here? Okay, so you'd be thinking maybe I should get the exact same output. So if I go and run this, I get the exact same output, and that's because I'm passing these numbers, num1 and num2, into the Ryan function. But then when I'm getting to the Ryan function, I'm renaming my parameters. Again, our parameters being num1 and num2. So I'm changing their names from num1 to n1, and I'm changing num2 to n2. So for example, if I delete these and I try and run this, we're going to run into a problem, because when I tried this before, I used num1 and num2, but now I'm trying to print out n1 plus n2, but we don't really know what this is because we haven't defined it inside our function here as parameters. So let's go and run this and see what we get. And again, you can see we get an error, and basically what it's saying is it doesn't really understand what n1 is because it can't find n1. So I need to go and put n1 back in here along with a comma and n2, and now it knows that n1 and n2 are parameters that we're getting in from this Ryan function. And then we go back and see where this Ryan function is called, and we can see that it's been passed in num1 and num2, and if we go back again we can see num1 and num2 are actually these two numbers here, okay? So if I go and run this time, we should get our original result with hello, and then our number, which is 11, and then our world printed out. So calling this function Ryan isn't a great name, so we might say maybe add nums. That seems like a better name than Ryan, because add nums makes more sense because that's exactly what we're doing within this function. So if we go and run this now, again, remember, we haven't changed this here. So if we go and run this, we're going to run into a little bit of an issue. And you can see we've got another error similar to before. We forgot to change the name from Ryan to add nums. That's super important. So if we go and run this again, we should get the previous result. And so we do. Hello, 11, and world. So this is the power that we have with passing in variables. And the reason why it's good to have these parameters named rather than using these num1 or num2 variables is because we don't always know what num1 and num2 are. So for example, this add nums could be called multiple times, and it's not just passing in num1 and num2, but it's passing in loads of different combinations of numbers. So I could have, let's say, a num3 here and a num4. So I might just go and copy this and paste it in. I need to change these names, so I'm going to change that to num3 and num4, and I'm going to change this from 5 to 15, and I'm going to change this from 6 to 10. Okay, so now rather than going and changing this and changing this, I can just go and change this. So I no longer want to pass in num1 and num2. Now I want to pass in num3, which is 15, and I want to pass in num4. And if I go and run this now again, I'll see my output as 25, because 25 is equal to 15 plus 10. Now if I still had, let's say, num1 and num2 in here, if I go and run this again, now I will see that I get this hello 11 world. And this is not right, because I've created this function add nums, and I've called the function add nums, and I've passed in the number 3 and the number 4, but that's not what I'm getting. I'm getting the total of num1 and num2. That's because num1 and num2 are within my function. They're hard coded in there, and we don't want that. We want to be able to access whatever numbers are passed into the function. So I'm going to change this back to n1 and n2, and if I go and run this again, we should see our previous result, and so we do. We see the number 25 being displayed. Hi everyone, in this video we're going to be working with functions again, but unlike last time where we took in parameters and we just printed out the result within that function, in this video we're going to be returning a value from a function which we can go and then display it out in the main program and not inside the function like we did in our last video. So this video is going to be pretty similar to our previous video, so if you haven't seen that, I would suggest to watch that first. And as you can see, we have this hello at the top. We can take this out because we no longer need it. And then we have 4 different variables, num1 to num4. And then we have our function. Our function is called add nums, and it currently takes in 2 values. So we could change these to num1 and num2 rather than having them num3 and num4. It doesn't matter. We're going to change it back at the end of the video to make sure the program works for both. And once we define our function here, add nums, we take in 2 parameters. This is n1 and n2. Keep in mind that this n1 and n2 is nothing got to do with the names of these functions here. So for example, this here, instead of n1, it could be anything. We could call this x, and we could call our second value y, and if we did that we would have to replace this here with x and y. And if we go and run this now, we can see that we get our result as 11, and then world shows up as well. So in this program, world is not actually needed, so we can also get rid of this. But I'm going to change my variables back to n1 and n2 because I think it makes a little bit more sense than having x and y. X and y doesn't really mean anything, at least n stands for number. So now that we've changed that back, I'm just going to go and run it again to make sure that it's still working. And you can see that I don't get the right result, so I made a little typo here. It should be n1 plus n2, And that's why it's always really important to keep running your program, because you might know what the mistake is and you want to change it to something, and when you go and change it, like myself, you make a little bit of a typo and then you end up getting the wrong result, and then that could lead to more problems later on down the line, and you've wasted more time debugging. So it's always a good idea to keep running your code, keep seeing the output to make sure that you are getting the values that you should be getting. So the next thing I want to talk about is returning a value. So for example, we could return n1 in this example, right? So if we're going to return a number, we don't really want our console log here, or we could keep it in. So I'm just going to keep it in for now, and I'm going to use the return keyword. And after return, I'm going to put in whatever value I want to return. So in this case, I want to return n1. So n1 will be returned to this function call here. Now, the problem with me returning a value from this function addNums, it's not going to be stored in anything. So what we could do is we could go and console log this whole function call that we've made here, and the output that we should get is n1. So if I go and run this, we can see that our output is 11 because we're getting our 11 from this function here, because this function is called first. And then we're returning n1. Now n1 is 5. If we look up here, that's what we're passing in. We're passing in num1, which is 5. Then we're changing that num1's name to n1 in this function. And then at the end of this function, we're returning n1 to wherever it was called, and it was called here on line 7. And to actually see what return value we get, we have to use a console log. So that's why we have a console log and our addNums function inside of it. We could also assign this function to a variable. So I could just say res, short for result, and I'll define that as a let, and after res is our variable name, just the same way as this is num3 or this is num4. This is just a variable name, and I can get rid of that bracket at the end as well because it's no longer needed. And if we go and run this now, we won't see 5, okay, but 5 will be stored in this res. So if I go and hit run, we can see the number 11 gets displayed. So if I want to now make sure that res does in fact hold the number that we're returning, n1, which should be 5, we can do a console log. So I'll say console.log, and I'll put the variable res inside our console log, and if I go up here and run our program again, we get the output 11 and 5. So we don't really want this console log here anymore. So we don't want it to console log 11 inside the function. We want to go and return our value. So I'm just going to get rid of this now. And as you can probably guess, since I've deleted this line from addNums, the only number that gets displayed now is 5. We don't want to just return n1. We want to return the combination of n1 plus n2. So what we could do is we could create a const, and we could set this const equal to a variable. It could be anything. I'm just going to call my variable return value, and I'm going to set that value equal to n1 plus n2. And now I'm no longer going to return n1, but I'm going to return my return value variable. And if I go up here and run this again, I get the output as 11, because that's what the total of n1 and n2 are. So if I was to change the numbers that I was passing in, so instead of num1 and num2, maybe if I put num3 and num4 in here, I should get a different result. So if I go up here and run again, I get the output as 25. and that's what the total of num3 and num4 are equal to. So the next thing I can do to just clean this code up a little bit more is, rather than defining our const return value here and then setting this as our return value, we could just return n1 plus n2. So if I copy this and I paste this in here, and now I'm going to delete this line because I no longer need it, and I go up here again and hit run and run without debugging, I get the answer 25. So this is a really simple example. We're only passing in a couple of numbers and we're only just adding the two of them together. So it would be a good idea to get used to this simple functionality of functions. So creating a function, being able to call that function, being able to pass in parameters, and then of course be able to return values from the function. In our next video, we're going to talk about recursion, where a function has the ability to call itself. Hi everyone, in this video we're going to be talking about functions, and we're going to be creating a special type of function called a recursive function. Now, in the previous videos we've defined functions before, we've called functions, we've passed parameters into our functions, and we've even returned values from our function. But in this video we'll be doing something slightly different with using a recursive function. Now, a recursive function is a function that calls itself. So let's start off by defining our function. So if you've been following along with the previous videos, I'm going to just delete everything and we're going to start from scratch by creating a simple function to start off with. So to create our function, we'll use the keyword function followed by a name, and we're just going to call this function test. And test is going to take in a parameter, but we're not going to include that just yet. And we're going to have two curly brackets. Now we're going to pass in a parameter here in a second. We're going to pass in a number, but just for this first example, we're not going to pass in any numbers. And inside our test function, we're going to just do a simple console log test. So we've now defined our function test, and we're going to get it to console log out the text test every time it's called. So if we go and call our function like this, and we go and run our program, we should see our output as test. And so we do. Now what we want to do is we want to call this function inside the function. So we want to do this. We can copy our test call and we can place this inside our test function. So what's going to happen is we're going to start off here on line 1. We're going to go to the test function and call it. So this is it here. Then once we go inside, we're going to console log test. And then after we've console logged test, we're going to go and call our test again. So we're going to jump back up here and we're going to console log test. Then we get down here again, we call the function console log.test, it's called again, and so on and so on. So if you remember with our while loop, this sounds pretty similar to that, but you'll see the problem that we encounter now in a second. So if I go and run this, you can see, oh, we've got a problem. So if we go up here, if you scroll up, you can see there has been a lot of tests printed out, and there's probably a few hundred different tests printed out. And then as we get to the bottom, we get this error message, right? And the problem that we get is basically that the maximum call stack size has exceeded whatever we have on our machine. Now, for some machines, tests will be printed out more. On better machines, you'll be able to print out more of these tests before you run into this error. On machines that are not as good, you're going to reach this error pretty quickly. So the problem that we have is we are stuck in an infinite loop, basically, because we have our function that's calling the function, which calls the function, which calls the function, so it never ends. So we need to do something to try and prevent this from happening. Okay, so we need to use a conditional statement, and we can do this by using an if statement. So we can say if something is true, then return 1, and once 1 is returned, then our function will be ended. But if it's not 1, or let's say if our num is not less than 1, we want to go and call our test function. But to do this, we need to go and pass in a number. So we're going to start off here. Once we call our test function, we're going to pass in a number. I'm going to put the number 5, that's what we're going to use for this example. And now we're going to pass 5 into test, and we'll call this num. So we want to go and now check to see if num is less than 0. We want to go and return something. So we want to go and we could say return 1. So this basically means once num is less than 0, it's going to return 1, and once it returns 1 from this function will end. But if this condition is not true, it will be skipped. So then it will console log test, and we're going to go and call test again. So what we're going to pass into this test function will be num minus 1, because we can't pass in just the num that we have here, which is 5, because again we'll have the same issue. It'll keep going and going and never end. So that's why we have num minus 1. So if I go and run this again, we see that test is printed out 6 times. And rather than having test, we could have something that gives us a little bit more insight. So we could say num here instead. So if I go up here and I click run again, we can see that we start off with the number 5 because that's what we've passed in. Then we go and print out that number 5. Well, initially we first of all check to see if the number that is passed in here is less than 0. It's not, so this is skipped. Then console log our number, which is 5. That's what we passed in. Then we go and call test again with the num, which is 5 minus 1, so that's 4. So then we go back up here again to test. Now this time it's num minus 1. Num is 5 minus 1, that's 4. So again, 4 is still not less than 0, so this is skipped. Then we console log this. This is 4 in this case. And then we get down here, and our current num at this stage is 4. So if our current num is 4 minus 1, which is 3, now this function is called again. Again, this is skipped, and this is console log the number 3, and then so on for the other numbers. And that's what a recursive function is.